Around 12,800 years ago, Earth's climate was warming steadily as the last ice age retreated. Glaciers that had covered much of North America and Europe for millennia were melting. Sea levels were rising, and the world was becoming more hospitable. Then abruptly, temperatures plunged. In some regions, the cold returned as severely as it had been during glacial peaks. Glaciers that had been melting for thousands of years began advancing again. Megafauna that had survived the Ice Age, mammoths, giant sloths, saber-toothed cats, went extinct across multiple continents. The archaeological record shows human populations declining sharply. And then, just as suddenly, 1,200 years later, the cold snap ended. This period is called the Younger Dryas, named after a hardy alpine flower that spread across Europe when the tundra returned. It represents one of the most dramatic climate reversals in recent geological history. Ice core data from Greenland shows temperature drops of 10 degrees Celsius or more happening within decades, possibly within years. That's not gradual climate change. That's catastrophe. For a long time, the cause was debated. Most scientists favored a disruption of ocean currents. The theory held that massive influxes of glacial meltwater into the North Atlantic shut down the Gulf Stream, cutting off the warm water that keeps northern regions temperate. Without that heat circulation, Europe and North America plunged back into Ice Age conditions. It was a tidy explanation, well supported by oceanographic models. But in recent years, a more controversial hypothesis has gained traction. In 2007, a team of researchers led by Richard Firestone published evidence suggesting that the Younger Dryas was triggered not by melting ice, but by cosmic impact. Fragments of a comet or asteroid, they argued, struck Earth around 12,800 years ago, causing widespread destruction and climate chaos. The evidence they presented was striking. Across North America, Europe, and parts of Asia, sediment layers dating to the onset of the Younger Dryas contain anomalies. Platinum concentrations spike far above normal levels, consistent with extraterrestrial material. Nanodiamonds appear, microscopic crystals that form under extreme pressure and temperature, the kind produced by cosmic impacts. Magnetic spherules, tiny balls of melted rock, litter the layer. And at some sites, a black carbon-rich layer covers the landscape, suggesting widespread wildfires. The Black Man, as it's called, appears at dozens of sites across North America. It's a dark, organic-rich sediment that sits directly atop the end Pleistocene layers. Below it, megafauna bones are common. Above it, they vanish. The timing matches the Younger Dryas boundary almost perfectly. Something happened that left a continent-wide signature of burning and death. One of the most compelling pieces of evidence comes from Abu Huraira in Syria. This archaeological site, now submerged beneath a reservoir, was excavated before flooding. Researchers found glass-like carbon formations in the Younger Dryas boundary layer, formed when organic material is subjected to temperatures exceeding 2,200 degrees Celsius. That kind of heat doesn't come from normal wildfires. It requires either volcanic activity or airburst explosions. The hypothesis proposes that fragments of a disintegrating comet struck the Laurentide ice sheet covering North America, as well as northern Europe. The impacts and airbursts would have melted portions of the ice instantly, sending massive floods across the landscape. The impact debris, dust, soot, and aerosols would have darkened the skies, triggering a nuclear winter-like cooling. Wildfires ignited by airbursts would have burned across continents, and the sudden influx of meltwater into the oceans would have disrupted currents, prolonging the cold period. If true, the scale of destruction would have been immense. The Clovis culture, which dominated North America at the time, disappears from the archaeological record right at the Younger Dryas boundary. Their distinctive spear points, common before 12,800 years ago, become rare afterward. Whether this represents population collapse, cultural transformation, or simple coincidence remains debated, but the timing is suggestive. Megafauna extinctions add another dimension. 34 genera of large mammals in North America went extinct during or shortly after the Younger Dryas. Mammoths, mastodons, giant ground sloths, short-faced bears, American horses, and camels all vanished. In Europe and Asia, similar losses occurred. Some researchers argue that overhunting by humans drove these extinctions. Others point to climate change. The impact hypothesis offers a third explanation: catastrophic environmental destruction that neither animals nor humans could survive. Yet the theory remains controversial. Mainstream archaeologists and geologists have raised significant objections. Some argue that the platinum and nanodiamonds can be explained by earthly processes. Wildfires alone might account for the carbon spherules. The black mat, critics suggest, could be the result of normal post-glacial environmental changes rather than impact. And crucially, no impact crater from this period has been found, though proponents argue that impacts on ice sheets would leave no crater, and airburst explosions don't create craters at all. Studies published in the past decade have gone back and forth. In 2018, researchers found platinum spikes in ice cores from Greenland, precisely at the Younger Dryas boundary, supporting the impact theory. In 2019, a large impact crater was discovered beneath the Hiawatha Glacier in northwestern Greenland, dated to roughly the right period, though dating ice-covered craters is difficult and the connection remains uncertain. Other studies have failed to replicate some of the original findings, casting doubt on the universality of the impact markers. The academic debate is ongoing, and that's how science works. Extraordinary claims require extraordinary evidence, and the impact hypothesis is being scrutinized accordingly. What's not in dispute is the climate event itself. The Younger Dryas happened. Temperatures plummeted, ice advanced, ecosystems collapsed. Whether the trigger was impact, ocean circulation, volcanic eruptions, or some combination is still being worked out. What matters for the question of lost civilizations is this: for more than 1,000 years, Earth became dramatically less hospitable to complex human societies. If any advanced cultures existed during the warming period before the Younger Dryas, their traces would have been scoured by advancing glaciers, buried under flood deposits, or simply lost as populations crashed and dispersed. The archaeological record from this period is sparse. Sites are rare. Evidence is fragmentary, and that's in regions we can still access. Much of the landscape inhabited during the warm period before the Younger Dryas now lies beneath ocean waters or under thick sediment layers. Imagine a map of North America 12,000 years ago. Populations are spreading as the ice retreats. Groups are settling near ice margin lakes, following herds, perhaps experimenting with early forms of plant management. Then comes the impact. The sky fills with smoke and dust. Temperatures drop within years. The ice that had been retreating begins advancing again. Lakes drain or freeze. Herds scatter or die. Surviving humans retreat south, abandoning settlements, leaving behind only what they cannot carry. And over the next centuries, as glaciers grind forward and floodwaters surge, those abandoned sites are erased. The Younger Dryas may explain why evidence for advanced prehistoric cultures is so elusive. It represents a natural disaster, severe enough to erase entire landscapes. But some achievements did survive. Massive stone constructions scattered across the globe, built with techniques that puzzle modern engineers. From Turkey, we now travel across continents to examine these impossible megaliths. In the mountains of Lebanon, 3 limestone blocks sit at the base of the Temple of Jupiter in Baalbek. Each weighs approximately 800 tons. They were quarried a quarter-mile away, transported uphill, and fitted so precisely that a knife blade cannot slip between them. No mortar holds them together, just their own staggering weight and the perfection of their placement. In Peru, at Sacsayhuaman, above Cusco, stones weighing over 100 tons interlock in walls with corners of 12 angles, each surface ground to meet its neighbor with microscopic precision. And no one knows how any of this was done. These aren't isolated examples. Across the globe, ancient builders created stonework that challenges modern understanding. The precision isn't approximate. It's exact. The engineering isn't crude. It's sophisticated. And the methods used remain largely mysterious, despite more than a century of archaeological study and engineering analysis. At Baalbek, the 3 stones forming the base of the temple complex are known as the Trilithon. Each block measures roughly 19 meters long, 4 meters high, and 3.5 meters deep. That's 800 tons of solid limestone. But the Trilithon isn't even the largest stone at the site. Nearby in the quarry lies the stone of the pregnant woman, a single block weighing over 1,000 tons that was partially cut from bedrock but never moved. Another block, discovered more recently, may exceed 1,600 tons. To put that in perspective, moving an 800-ton block today requires specialized cranes, hydraulic lifts, and carefully engineered support systems. Modern construction equipment struggles with loads of this magnitude. Yet at Baalbek, these blocks were quarried, shaped, transported a quarter-mile uphill, and placed with precision that allows no gaps between them. The joints are so tight that nothing can fit between the stones. The conventional explanation is straightforward. Massive labor, clever use of ramps and rollers, and an enormous investment of time. Ancient builders, according to this view, compensated for technological limitations with patience and manpower. Hundreds or thousands of workers could theoretically move such stones using rope, wood, and determination. Experiments have shown that large numbers of people can indeed move multi-ton blocks using primitive methods. But the precision is harder to explain. At Sacsayhuaman, the walls aren't built from rectangular blocks. They're polygonal, each stone an irregular shape that interlocks with its neighbors in 3 dimensions. Some blocks have as many as 12 corners, each surface meeting adjacent stones, with tolerances measured in fractions of millimeters. Run your hand along the joints and you feel no gap, no step, no irregularity. The stones fit as if they were poured rather than carved. The site sits at 3,700 meters above sea level on a hill overlooking Cusco. The larger stones weigh up to 200 tons. They're andesite, a volcanic rock harder than granite. Shaping andesite to this precision with bronze or stone tools would be extraordinarily difficult. Yet the Inca, who built Sacsayhuaman in the 15th century, had no iron tools and no wheels. Spanish chroniclers, who arrived shortly after the site was completed, marveled at the stonework and asked the Inca how it was done. The Inca reportedly said they didn't build it. It was already there, built by earlier people. Whether that's literal truth or cultural mythology is unclear, but it points to a recurring pattern. Many megalithic sites have uncertain origins, with later cultures occupying or modifying structures they claim were built by predecessors. At Sacsayhuaman, some archaeologists argue that the Inca added to earlier foundations, perhaps explaining why construction techniques vary across different sections of the walls. Ollantaytambo, another Inca site in Peru, presents similar puzzles. The Temple of the Sun features massive blocks of pink rhyolite, each weighing 50 tons or more. The stones came from a quarry 6 kilometers away, on the opposite side of the Urubamba River. Transporting them would have required crossing the river, climbing a mountainside, and fitting them together with precision that rivals Sacsayhuaman. Unfinished blocks still lie along the presumed transport route, suggesting that work was abandoned suddenly, possibly during the Spanish conquest. Easter Island offers another example of precision engineering applied on a different scale. The Moai, the famous stone heads, weigh up to 80 tons. They were carved from volcanic tuff at the Rano Raraku quarry, transported up to 18 kilometers across the island, and erected on stone platforms called ahu. The platforms themselves are constructed from carefully fitted basalt blocks, some weighing several tons. While the Moai have captured popular imagination, the platforms demonstrate sophisticated engineering that's often overlooked. There are fascinating tidbits in the details. At Baalbek, the quarrying technique involved cutting channels around the intended block and then using wooden wedges soaked in water to split the stone free. Marks from this process are still visible. At Sacsayhuaman, some researchers have noted that the stone surfaces appear polished or melted rather than chiseled, though this remains highly controversial. Mainstream archaeologists attribute the smooth finish to careful grinding with abrasive sand and water. Alternative theories about these sites range from the plausible to the fringe. Some suggest that ancient builders possessed advanced tools or techniques now lost to history. Bronze tools, for instance, could be alloyed in ways that made them harder and more effective than we assume. Others propose that acoustic or vibrational methods were used to soften or shape stone, though no evidence supports this, and physics argues against it. At the far end of speculation, some claim extraterrestrial assistance or lost technologies from advanced prehistoric civilizations. Mainstream archaeology maintains that conventional methods, given enough labor and time, can account for the megalithic sites. Experimental archaeology has demonstrated that teams of people using replica ancient tools can indeed move and shape large stones. In the 1990s, engineer Jean-Pierre Houdin proposed that the Great Pyramid was built using internal ramps, solving logistical problems that external ramps would have faced. Similar clever solutions, archaeologists argue, explain other megalithic achievements. Yet questions persist. At Pumapunku in Bolivia, which we'll examine in detail later, Stone blocks show drill holes and cuts so precise they appear machine-made. The tolerances are within fractions of millimeters, and the stones are andesite and diorite, ranking 6 to 7 on the Mohs hardness scale. Shaping such hard stone to such standards with soft copper or bronze tools would require extraordinary skill and time. The geographic distribution of precision megalithic stonework is itself intriguing. Sites appear in Lebanon, Peru, Bolivia, Egypt, Easter Island, and elsewhere, separated by thousands of miles, and in some cases, thousands of years. The techniques show similarities: polygonal masonry, precise joints, massive stone weights, but no clear evidence of contact or cultural transmission exists between these regions in conventional timelines. Some archaeologists point to convergent evolution, different cultures independently discovering similar solutions to similar problems. Others suggest the stoneworking knowledge was more widespread in antiquity than we recognize, passed along trade routes or migration paths that left few other traces. A few researchers propose an older shared source, a progenitor culture whose techniques were inherited by later civilizations. This last idea remains speculative, lacking direct evidence, but difficult to disprove conclusively. The engineering knowledge implied by these structures is undeniable. Someone understood load-bearing, balance, and the properties of stone. Someone could calculate the force needed to move massive weights and organize the labor to accomplish it. Someone knew how to cut, transport, and place stones with precision that modern masons admire. That knowledge existed. The question is how complete it was, how widespread, and what happened to it. At Ollantaytambo, unfinished blocks lie scattered along the transport route, abandoned mid-project. The Inca were actively working the site when the Spanish arrived, so we know their techniques included rope, wooden rollers, and earthen ramps. But does that mean the same methods built the most precisely fitted stones? Or were the Inca maintaining and adding to structures whose original construction methods had been forgotten? The challenge with megalithic sites is separating what we can prove from what we can only infer. We know the stones are there. We can measure their weights and analyze their precision. We can see tool marks and quarry scars. But the actual construction, the day-to-day process, is invisible. No ancient engineer left blueprints. No overseer wrote a construction manual. The stones exist, mute witnesses to vanished knowledge. How did ancient builders achieve precision that rivals modern laser cutting? Were these techniques gradually developed and lost? Or do they hint at knowledge systems more sophisticated than we've assumed? The stones themselves are evidence of incredible achievement. But the blueprints, the tools, the training schools, all of that is gone. What we're left with are monuments that seem impossible by the standards of their supposed age, standing silent across 4 continents. Precision stonework suggests advanced engineering knowledge, but there's another class of artifacts that hint at something even more intriguing. Ancient maps that appear to show coastlines that shouldn't have been known for centuries or even millennia. In 1929, a German theologian was cataloguing materials at the Topkapi Palace in Istanbul when he uncovered a gazelle skin parchment rolled away in the archives. It was a map beautifully illustrated, dated to 1513 and signed by an Ottoman admiral named Piri Reis. The map showed the Atlantic Ocean, the coasts of Europe, Africa, and South America. Nothing unusual there. Columbus had reached the Americas 2 decades earlier, but when cartographers examined it more closely, they noticed something strange. The southern portion of the map appeared to show the coastline of Antarctica, but not as it looks today beneath its ice sheet, but as it might have looked if the continent were ice-free. The Piri Reis map is one of the most controversial artifacts in alternative archaeology. To believers, it's evidence that ancient civilizations possessed geographic knowledge far beyond what conventional history allows, knowledge that could only have come from advanced maritime cultures predating the Ice Age. To mainstream scholars, it's a 16th century compilation that mixes accurate coastlines with creative speculation, producing coincidental resemblances that enthusiasts have misinterpreted. Piri Reis himself left notes on the map explaining his sources. He claimed to have used approximately 20 older maps as references, including charts captured from Spanish sailors and, intriguingly, maps that dated to the time of Alexander the Great. Whether such ancient sources actually existed or whether Piri Reis was embellishing his credentials is impossible to verify. The source maps he described have never been found. The map itself covers the Western Atlantic, showing the coasts of Europe and Africa with reasonable accuracy for the period. The South American coastline is recognizable, though compressed and distorted in ways typical of 16th century cartography. The eastern coast of South America appears relatively accurate, suggesting Piri Reis had access to Portuguese or Spanish charts from recent voyages. It's the southern portion that generates controversy. Below South America, the map shows a coastline continuing southward and then curving eastward. In 1960, Charles Hapgood, a professor of history and science, published a book arguing that this represented the coast of Antarctica as it would appear without ice. He claimed that the map showed details like the Ross Sea and Queen Maud Land with surprising accuracy, implying that someone had charted Antarctica when it was ice-free, perhaps thousands of years ago. Hapgood's work sparked decades of speculation. He proposed that ancient seafaring civilizations had mapped the world during a warm period before the last ice age, and that these maps were copied and recopied through successive cultures, eventually reaching Piri Reis through intermediary sources. The theory was appealing. It explained the apparent anomalies and suggested a lost chapter of human achievement. But mainstream cartographers and historians have raised significant objections. First, Antarctica has been covered by ice for millions of years, not thousands. The idea that it was ice-free during human history contradicts geological evidence. Ice cores from Antarctica show continuous glaciation stretching back far beyond the time frame Hapgood proposed. If humans mapped an ice-free Antarctica, they would have had to do so millions of years ago, long before modern humans existed. Second, the resemblance to Antarctica's coastline is debatable. When examined without preconception, the southern portion of the Piri Reis map doesn't clearly match Antarctica's actual geography. The scales don't align, the orientations don't match. What Hapgood identified as the Ross Sea could just as easily be interpreted as a speculative extension of South America or a mythical land drawn from rumor and imagination. 16th century cartographers routinely filled in unknown regions with educated guesses, copying from earlier maps that themselves contained errors and speculation. The concept of Terra Australis, a hypothetical southern continent, had circulated since classical times. Cartographers believed that a massive landmass must exist in the southern hemisphere to balance the known northern continents. Puri Reis may simply have drawn what he thought should be there based on theoretical geography rather than actual exploration. Other controversial maps have similar claims attached to them. The Oronteus Phineas map of 1531 shows a continent in the southern polar region with rivers, mountains, and coastlines. Supporters argue it depicts Antarctica before glaciation. Critics note that the continent is far too large. The details don't match Antarctica's actual topography, and the entire image could be an artistic interpretation of Terra Australis Incognita. The Boache map of 1737, created by French cartographer Philippe Boache, shows Antarctica as two separate landmasses divided by a channel. Modern surveys using ice-penetrating radar have revealed that beneath the ice, Antarctica is indeed divided by a submarine trench. Does this prove Boache had access to ancient maps showing pre-glacial Antarctica? More likely, Boache was making an educated guess based on the assumption that Antarctica, like other continents, probably had varied topography with channels and straits. There are intriguing details that keep the controversy alive. Piri Reis's notes mention that his sources included maps from the time of Alexander the Great. If true, that would place some of his reference material in the 4th century BCE or earlier. But we have no way to verify this claim. No such maps survive, and Piri Reis may have been inflating the pedigree of his sources to enhance his own reputation. Some researchers have pointed to specific features on the Piri Reis map that seem oddly accurate. The placement of certain islands, the shapes of bays, and the general configuration of coastlines match real geography in ways that seem too precise for guesswork. But cartographic historians argue that these accuracies can be explained by Piri Reis's access to Portuguese and Spanish charts, which by 1513 were quite detailed for explored regions. The real question is whether any ancient maps existed that could have served as Piri Reis's sources. We know that ancient civilizations engaged in maritime trade and exploration. The Phoenicians, Greeks, Romans, and later Arab traders all created maps, most of which have been lost. Parchment and papyrus decay. Libraries burn. The Library of Alexandria, which once held hundreds of thousands of scrolls, was destroyed over centuries through various disasters and conflicts. How many maps and charts were lost with it? It's plausible that geographic knowledge accumulated over centuries was lost and then partially rediscovered. The Phoenicians circumnavigated Africa around 600 BCE, according to Herodotus. If they did, they must have had charts. None survive. The Polynesians navigated the Pacific for thousands of years, reaching islands separated by thousands of miles of open ocean, using mental maps and stick charts. Could other cultures have possessed similar navigational knowledge that simply wasn't preserved in forms we can recognize today? The problem with the Piri Reis map as evidence for lost civilizations is that the claims require either an ice-free Antarctica in human times, which geology disproves, or advanced ancient seafaring cultures that left no other trace. If such cultures existed, we'd expect more evidence than ambiguous coastlines on 16th century maps. We'd expect ruins, shipwrecks, ports, and artifacts scattered across the regions they explored. Some alternative researchers point to underwater structures off various coastlines as possible evidence. But most of these have been shown to be natural formations or modern constructions. The Yonaguni Monument off Japan, for instance, has been championed as an ancient submerged city, but geologists largely agree it's a natural rock formation shaped by tectonic activity and erosion, though the debate continues. What we're left with is ambiguity. The Piri Reis map exists. It shows coastlines with varying degrees of accuracy. It may have been compiled from older sources, some of which could have been quite ancient. But whether those sources contained knowledge from lost civilizations, or were simply the accumulated geographic understanding of successive maritime cultures, is impossible to determine without the sources themselves. The Piri Reis map remains a source of fascination and debate. Did it really preserve ancient geographic knowledge from a lost civilization? Or is it simply a 16th century compilation that mixed fact with fantasy, as maps of that era often did? Without the source maps Piri Reis claimed to have used, we cannot know. What we can say is that cartography, like memory, is fragile. Maps burn, libraries flood, knowledge once recorded can still disappear completely. If ancient civilizations did chart the world, where are their maps now? Maps hint at knowledge. But the Antikythera mechanism, dragged from the Aegean Sea in 1900, is proof, tangible, physical, undeniable, that ancient technology could be far more sophisticated than anyone imagined. In 1900, Greek sponge divers, sheltering from a storm near the island of Antikythera, dove into the clear Aegean waters and discovered a Roman shipwreck. Among the amphorae and bronze statues, they found a corroded lump of bronze gears. For decades, it sat in a museum, dismissed as a simple astrolabe or clock. It wasn't until the 1970s, when X-ray imaging revealed its internal complexity, that researchers realized what they had: an astronomical calculator of breathtaking sophistication, built around 100 BCE, a device with technology that wouldn't reappear in Europe until the 14th century. The shipwreck itself dated to approximately 60 BCE, based on pottery and coins found in the wreckage. The ship had been carrying luxury goods from the eastern Mediterranean, probably Rhodes or Kos, toward Rome. It went down in deep water off the rocky coast of Antikythera, and there it remained for 2,000 years until the divers stumbled upon it by chance. When the artifacts were brought to the surface and cleaned, most received immediate attention. Bronze statues of heroes and philosophers, marble sculptures, jewelry. These were treasures that museums could display and scholars could study. But the corroded mechanism was puzzling. It looked like nothing anyone had seen before. The gears were obvious, but their purpose was unclear. Early researchers assumed it was some kind of navigational instrument or a simple clock. In 1951, British science historian Derek de Solla Price began a detailed study of the device. Using what technology was available at the time, he determined that it was far more complex than anyone had imagined. It wasn't a simple clock. It was a calculator designed to predict astronomical phenomena. But the full extent of its sophistication wouldn't become clear for another 2 decades. In the 1970s, X-ray tomography allowed researchers to see inside the corroded bronze without further damaging the fragile fragments. What the X-rays revealed was extraordinary. The device contained at least 30 interlocking bronze gears arranged in a complex system of wheels and dials. The gears were cut with precision, their teeth carefully shaped to mesh smoothly. Some gears were simple, others were compound, with multiple gears fixed together to achieve specific mathematical ratios. The front of the device featured a large dial marked with the zodiac and the Egyptian calendar. Pointers moved across the dial, driven by the internal gears, indicating the positions of the sun and moon against the background stars. The back had two additional dials, spirals marked with divisions that corresponded to cycles known to ancient astronomers. The Metonic cycle, a 19-year period, after which lunar phases repeat on the same calendar dates, and the Saros cycle, an 18-year period used to predict eclipses. Turning a handle on the side would advance all the gears simultaneously, moving the pointers to show the sky at any past or future date. Want to know where the moon would be 3 years from now? Turn the handle, read the dials. Need to predict the next eclipse? The Saros dial would tell you. It was, in effect, an ancient computer, mechanical rather than electronic, but computing nonetheless. The precision of the gears is remarkable. Each tooth had to be cut by hand, yet they mesh smoothly enough to turn freely after 2,000 years of corrosion and decay. The device included differential gears, a type of mechanism that wouldn't appear again in known technology until medieval Islamic clockwork and later European mechanical clocks. Differential gears allowed two inputs to combine into a single output, essential for calculating complex astronomical relationships. More recent studies using advanced imaging techniques have revealed even more detail. Inscriptions on the device describe its functions and provide something like an instruction manual. The text mentions the planets, suggesting the mechanism may have tracked their movements as well, though the gears for this function haven't survived or haven't been identified in the fragments we have. Some researchers estimate that the original device may have contained as many as 70 gears. Michael Wright, a former curator at the Science Museum in London, built a working reconstruction based on the X-ray data and surviving fragments. His replica functions perfectly, demonstrating that the ancient design was not only theoretically sound, but practically executable. The device works exactly as the inscriptions claim, predicting lunar phases, solar positions, and eclipses with accuracy that would have impressed ancient astronomers. The Antikythera mechanism proves several things beyond doubt. First, ancient Greeks possessed far more sophisticated mechanical technology than we previously credited. Second, they understood astronomy and mathematics well enough to build computational devices that codified that understanding into working machines. Third, the technology to create precision-geared mechanisms existed in the Hellenistic period, centuries before historians thought such technology emerged. But here's where the mystery deepens. This is the only example of such a device that survives. We have no other geared astronomical calculators from antiquity. Not a single one. Roman writers don't describe them. Greek texts mention astronomical instruments, but nothing with this level of mechanical complexity. If the Antikythera mechanism represents a tradition of instrument making, where are the other examples? The most likely explanation is that such devices were rare and valuable, owned by wealthy patrons or institutions like schools of philosophy. They would have been made of bronze, a metal that's easily melted down and repurposed. When the Roman Empire collapsed and knowledge systems fragmented, the technology for making such devices was lost. Bronze artifacts were melted for their metal, libraries burned, the workshops that trained craftsmen in gear cutting and mechanical calculation disappeared. What survived was the Antikythera mechanism, and only because it sank in a shipwreck where corrosion fused the gears into a solid lump that looked like junk rather than valuable bronze. Had it remained on land, it almost certainly would have been melted down centuries ago. We would never know it existed. There are intriguing hints that similar devices may have existed. Cicero, writing in the 1st century BCE, mentions that Archimedes had constructed spheres that showed the motions of the sun, moon, and planets. He describes them as mechanical devices, not simple orreries. Could Archimedes have built something like the Antikythera mechanism 2 centuries earlier? The timeline would fit. Archimedes lived in the 3rd century BCE and was known for his mechanical inventions. But his devices are lost, known only from descriptions. Other classical authors mention astronomical instruments with moving parts, but the descriptions are vague. We don't know if these were simple armillary spheres or something more sophisticated. The Antikythera mechanism suggests that more sophisticated is possible. If one such device existed, others likely did too. The implications extend beyond astronomy. Building the Antikythera mechanism required knowledge of metallurgy, precision engineering, gear theory, and astronomical mathematics. It required a craftsman who could cut gears by hand to tolerances of less than a millimeter. It required designers who understood how to translate astronomical cycles into mechanical ratios. That's not simple technology. That's the foundation of a tradition, a school of knowledge passed from master to apprentice over generations. And that tradition vanished. By the medieval period, nothing like the Antikythera mechanism existed in Europe. The technology had to be reinvented from scratch. Islamic scholars preserved and expanded Greek astronomical knowledge, but even they don't seem to have possessed geared, calculating devices of this sophistication. When mechanical clocks emerged in medieval Europe, they represented a new invention, not a revival of ancient technology. The Antikythera mechanism stands as a cautionary tale about technological regression. Here was a device that embodied advanced engineering and scientific understanding. It worked. It was useful. Yet the knowledge to create it was lost so completely that when the device was rediscovered in 1900, no one could figure out what it was. For 70 years, it sat in a museum, its true nature unknown, until X-rays finally revealed the gears hidden inside the corrosion. Imagine turning the handle, watching the pointers move across the dials. The moon advances through its phases. The sun travels through the zodiac. The Saros dial ticks forward, counting down to the next eclipse. You're holding a machine that compresses years of astronomical observation into a single portable device. You can see the future of the heavens. And you're doing this in 100 BCE, 2,000 years before computers, before microchips, before electricity. The Antikythera mechanism proves beyond doubt that sophisticated technology can be lost completely. If this single device hadn't sunk in a shipwreck, if divers hadn't found it, if X-rays hadn't revealed its complexity, we would never know that ancient Greeks could build computers. How many other devices of similar sophistication existed and left no trace? And if complex gearwork could disappear for a millennium, what else might ancient civilizations have developed and then lost? The Antikythera mechanism shows that advanced technology can vanish. But sometimes what vanishes isn't the artifact itself. It's our understanding of what it was for. In the ruins of ancient Baghdad, archaeologists found a clay jar that might have been a battery, or might have been nothing of the sort. In 1936, while excavating a Parthian site near Baghdad, German archaeologist Wilhelm König discovered a peculiar clay jar. Inside was a copper cylinder, and within that, an iron rod. The metal showed evidence of corrosion by an acidic substance. When modern researchers built a replica and filled it with vinegar or lemon juice, it generated about 1 volt of electricity. Had König discovered a 2,000-year-old battery? Or was he looking at an ordinary storage vessel that happened to contain corroded metal? The site, called Kujut Rabu, dates to the Parthian period, roughly 200 BCE to 200 CE. The Parthians controlled a large empire stretching from the Euphrates to modern-day Afghanistan, rivaling Rome in wealth and power. They were sophisticated traders, metalworkers, and builders. But nowhere in Parthian records, nor in accounts from neighboring cultures, is there any mention of electricity or electrical devices. The jar itself is unassuming. It stands about 13 centimeters tall, made of yellowish clay with an asphalt seal at the top. The copper cylinder fits snugly inside, capped at the bottom and open at the top. The iron rod runs down the center of the cylinder, held in place by the asphalt stopper, but not touching the copper. When filled with an acidic liquid, vinegar, wine, or citrus juice, the combination of copper, iron, and acid creates a simple galvanic cell that produces a small electrical current. König's interpretation was bold. He proposed that the Parthians had discovered electricity and used these jars as batteries, possibly for electroplating gold onto silver jewelry. The theory gained attention, particularly after replications demonstrated that the device could indeed produce current. Television programs and popular science books embraced the idea of ancient batteries, presenting it as evidence of forgotten technology. But there are significant problems with this interpretation. First, no wires or conductors have been found. A battery is useless without some way to deliver the current to whatever you are trying to power or plate. No copper wire, no gold thread, no conductive materials that would suggest the jars were connected to anything. Second, similar jars have been found at other sites, and some contain the remains of papyrus scrolls. The copper cylinder and iron rod may have been intended to preserve documents, not generate electricity. Third, the voltage produced is minimal, around 1 volt. To electroplate effectively, you'd need higher voltage or multiple cells connected in series. No evidence suggests the Parthians understood serial or parallel electrical circuits. And crucially, electroplating requires more than just current. It requires understanding of electrical chemistry, preparation of plating solutions, and careful control of the process. There's no evidence the Parthians possess any of this knowledge. Alternative explanations are more prosaic, but more plausible. The jars may have been scroll cases, designed to protect valuable documents from moisture and decay. The copper cylinder would provide a barrier, the asphalt seal would keep water out, and the iron rod might have served as a spindle for rolling the scroll. Similar containers have been found in Mesopotamian contexts, used specifically for document storage. Another possibility is that the jars served a ritual or religious function. Ancient cultures often created elaborate containers for sacred objects or offerings. The specific combination of materials, copper, iron, asphalt, might have had symbolic rather than practical significance. Without understanding the cultural context, we can't rule out ceremonial uses. The electroplating theory persists partly because of modern experiments. In 2005, the television show Mythbusters built replicas of the Baghdad battery and successfully used them to electroplate a small object. They demonstrated that it's technically possible to use such a device for plating. But possible doesn't mean actual. The ancient Romans could have built steam engines. The principles were known, and toy steam devices existed, but they didn't build steam engines for practical use. Similarly, the Parthians could have stumbled onto electrochemical reactions without understanding or exploiting them. The real problem is context. Koenig's excavation in 1936 was not conducted with modern archaeological standards. Documentation was minimal. The exact location where each jar was found, what it was associated with, and what else was in the immediate vicinity. All of this information is either vague or missing entirely. Without context, objects can be interpreted in almost any way. To make matters worse, the 2003 looting of the Baghdad Museum during the Iraq War resulted in the loss or damage of numerous artifacts, including some of the so-called battery jars. What remains is scattered across different institutions, and detailed analysis is difficult. We can't easily verify Koenig's original observations or conduct new tests on all the specimens. There's an interesting parallel with other enigmatic objects from archaeology. The Phaistos disc, a clay disc from Crete, covered with mysterious stamped symbols, has been interpreted as everything from a calendar to a board game to a prayer. The Antikythera mechanism was misidentified for decades. The Piri Reis map has been claimed to show everything from Antarctica to alien landing sites. When we don't understand an object's purpose, interpretation fills the void, often revealing more about our assumptions than about the object itself. The Baghdad battery illustrates how fragile archaeological interpretation can be. Without written records explaining the object's use, without other examples showing variations or improvements, without contemporary accounts mentioning the technology, we're left guessing. The jar, the copper, the iron, they exist, but their purpose is inference, not fact. Modern scholarly consensus leans toward non-battery explanations. Most archaeologists who have examined the jars believe they were scroll containers or ritual objects. The electrical properties, while real, are considered coincidental, a byproduct of materials that happen to create a galvanic cell when combined, not evidence of intentional electrical technology. Yet the ambiguity lingers. If the jars were scroll cases, why use iron rods rather than wooden spindles, which would be lighter and easier to work? If they were ritual objects, why are they so utilitarian in design, lacking the decoration typical of ceremonial vessels? The questions don't prove the battery theory, but they show how little we actually know. The Baghdad battery illustrates a frustrating truth about archaeology. Without context, objects can mean almost anything. Was it a battery? A scroll case? A cult object? We simply don't know. Koenig's original excavation records are incomplete, and the 2003 looting of the Baghdad Museum means some of the artifacts may be lost forever. What we're left with is a jar, some corroded metal, and endless speculation. And that raises the uncomfortable possibility. How many other ancient technologies have we found but failed to recognize? Clay jars can be ambiguous. But what about texts that explicitly describe advanced technology? In ancient Sanskrit literature, descriptions of flying machines called vimanas fill numerous verses. Are these metaphors, mythology, or memories? In the ancient Sanskrit epic Ramayana, the demon king Ravana flies through the air in a palatial vimana, a flying chariot described in meticulous detail. In the Mahabharata, warriors battle in the sky using devastating celestial weapons. And in the Vaimanika Shastra, a text claiming ancient authorship but compiled in the early 20th century, entire chapters describe the construction, piloting, and combat capabilities of flying machines. To believers, these are evidence of ancient advanced technology. To mainstream scholars, they are mythology and, in some cases, 20th century fabrications. The truth, as always, lies buried beneath layers of interpretation. The term Vimana appears throughout ancient Indian literature. In its most common usage, it simply means a chariot or vehicle, often associated with gods or powerful beings. But in certain contexts, particularly in the great epics composed between 500 BCE and 400 CE, vimanas are described as airborne vehicles with remarkable capabilities. In the Ramayana, Ravana's vimana, called Pushpaka, is described as a palace that can fly, capable of traveling great distances and carrying many passengers. It moves at the command of its pilot, rising into the air and descending at will. The text describes it as being made of gold and precious materials large enough to hold entire armies. After Ravana's defeat, the hero Rama uses the Pushpaka Vimana to return home, flying over mountains and forests. The Mahabharata contains similar descriptions. Aerial battles occur between gods and demons, with vehicles that shoot weapons resembling fire and thunder. One passage describes a weapon called the Brahmastra, so powerful it could destroy entire armies, producing effects that sound eerily like nuclear explosions. Intense heat, blinding light, devastation over wide areas. Some modern readers have interpreted these descriptions as memories of ancient atomic warfare, though mainstream scholars see them as poetic exaggeration and a mythological hyperbole. The most controversial text is the Vaimanika Shastra. In the 1920s, Pandit Subbaraya Shastri claimed to have channeled this ancient text through mystical revelation. The manuscript describes several types of vimanas in technical detail, listing materials for construction, propulsion methods, and even defensive capabilities. It reads like an engineering manual, specifying metals, giving measurements, and explaining operational procedures. When the Vaimanika Shastra was published, it generated excitement among those inclined to believe in ancient advanced technology. Here, finally, was a detailed technical document about flying machines. Proponents argued it represented genuine ancient knowledge preserved through oral tradition and now written down. The level of detail seemed too specific to be mere invention, but scholars quickly identified problems. First, the text itself was not ancient. Shastri claimed to have received it through psychic channeling, not from any physical manuscript. No earlier copies exist. No references to such a text appear in classical Indian literature. The earliest mention of the Vaimanika Shastra dates to the 1920s, making it a modern composition regardless of its claimed origins. Second, when aeronautical engineers examined the technical specifications, they found the designs unworkable. The proposed propulsion systems violate basic physics. The structural designs would be unstable. The materials specified would not provide the properties claimed. In 1974, a study by researchers at the Indian Institute of Science concluded that the Vimanas described in the Vaimanika Shastra could not fly. The text, they determined, was either fantasy or fraud. Third, some of the terminology and concepts in the Vaimanika Shastra appear to be borrowed from early 20th century Western aviation. The text mentions concepts like aerodynamics and metallurgy in ways that suggest the author was familiar with contemporary science but lacked deep understanding. Rather than ancient knowledge, it reads like speculative fiction, written by someone with a passing familiarity with modern technology. This doesn't necessarily invalidate all references to Vimanas in ancient literature. The Ramayana and Mahabharata are genuine ancient texts, and their descriptions of flying vehicles are part of the original compositions. The question is whether these descriptions are meant literally or metaphorically. Sanskrit scholars emphasize that the epics are not historical documents. They're religious and philosophical texts that mix mythology, allegory, and moral teaching. The flying chariots of the gods serve narrative purposes, allowing divine beings to travel between realms and intervene in human affairs. Expecting them to be blueprints for actual aircraft is like reading Greek mythology and trying to reverse engineer Pegasus. Yet some descriptions are oddly specific. The Ramayana describes the Pushpaka Vimana as having multiple levels, windows, and comfortable interiors. The Mahabharata mentions Vimanas made of different materials with different capabilities. While these details enhance the narrative, making the flying vehicles seem more real within the story, they don't constitute evidence of actual technology. There's also the question of genre. Ancient epics routinely featured supernatural elements. Heroes had divine weapons. Gods descended from heaven in celestial vehicles. Demons possessed magical powers. These elements were understood as part of the mythological framework, not as literal descriptions of historical events. To single out the Vimanas as potentially real while ignoring the talking animals, shape-shifting demons, and weapons that could boil the oceans is to cherry-pick details without respecting the text's overall context. Comparison to other mythologies is instructive. Greek myths feature Helios driving the sun across the sky in a chariot. Norse mythology has gods traveling in flying ships. Biblical texts describe Ezekiel's vision of a wheeled vehicle in the sky, attended by angelic beings. Each of these has been interpreted by enthusiasts as evidence of ancient aviation or alien visitation. Yet scholars recognize them as religious symbolism, using the language of material objects to describe spiritual or cosmic concepts. The appeal of literal interpretations is understandable. Ancient texts describing flying machines sound like science fiction, and science fiction has a way of becoming science fact. If Leonardo da Vinci could envision helicopters centuries before they were built, why couldn't ancient Indians have imagined or even created flying vehicles? The problem is evidence. Leonardo left sketches and notes that we can examine. The Vimanas of the epics exist only as poetry. There are cultural sensitivities to consider as well. The Sanskrit epics are sacred texts for millions of Hindus. Treating them as technical manuals rather than spiritual literature can be seen as reductive, missing their deeper meanings in pursuit of surface-level sensationalism. At the same time, dismissing the texts entirely as primitive mythology disrespects their sophisticated philosophical and literary qualities. The balance lies in appreciating the texts for what they are, masterpieces of ancient literature that use vivid imagery and supernatural elements to explore profound questions about duty, morality, and the nature of existence. Modern aviation has inspired new readings of ancient texts. Once humans actually achieved flight, it became easier to project that achievement backward, seeing hints and echoes in older stories. But this can create a kind of confirmation bias, where we find what we expect to find. Every flying chariot becomes a prototype aircraft. Every celestial weapon becomes a missile. The texts haven't changed, but our interpretation of them has, shaped by our own technological context. The Vimanas remain what they've always been, elements of sacred poetry. They allow gods to move between heaven and earth, heroes to journey across impossible distances, and narratives to unfold on cosmic scales. Whether they represent anything beyond that, memories of lost technology, encounters with advanced visitors, or prophetic visions of future flight, requires evidence that simply doesn't exist. So are Vimanas evidence of ancient flight? Or are they what they appear to be? Mythological vehicles in sacred poetry woven from imagination and religious allegory. The texts exist, rich with detail, but poetry has always been detailed. Myths have always been vivid. Without physical evidence, no wreckage, no landing sites, no contemporary accounts from other cultures, the Vimanas remain where they've always been, suspended between earth and imagination, neither quite real nor wholly invented. What we're left with are stories, and stories, however compelling, cannot replace artifacts. Sanskrit texts describe flying machines that left no trace. But in the highlands of Bolivia, stone blocks sit on the ground that seem to defy explanation, not because they fly, but because no one can explain how they were cut with such precision. At 12,800 feet above sea level on the cold Altiplano of Bolivia lie the ruins of Pumapunku. To the untrained eye, it's just a field of scattered stones, broken, weathered, covered in lichen. But pick up a measuring tool, and something remarkable appears. Flat surfaces machined to within fractions of a millimeter, perfectly square corners with 90-degree angles that would satisfy a modern engineer. H-shaped blocks with precise interlocking grooves, all carved from red sandstone and andesite, some of the hardest stones on Earth, and all done, supposedly, by a civilization with no writing, no iron tools, and no wheels. Pumapunku sits within the larger Tiahuanaco complex, one of the most important archaeological sites in South America. The Tiahuanaco culture flourished here between roughly 300 and 1000 CE, building a city that, at its peak, may have housed 40,000 people. The site includes temples, platforms, courtyards, and residences, all constructed with the massive stone blocks that characterize Andean architecture. But Pumapunku stands apart. Even among the impressive ruins at Tiahuanaco, it represents something exceptional. The precision of the stonework exceeds what's found elsewhere at the site. The blocks are larger, heavier, and more carefully finished. Some weigh over 100 tons. The largest may exceed 130 tons, though exact weights are difficult to determine for buried or broken stones. The material itself presents challenges. Most of Pumapunku is built from two types of stone, red sandstone and andesite. The sandstone is relatively soft and can be worked with copper or bronze tools, though it requires patience. But andesite is different. It's an igneous rock formed from volcanic activity, extremely hard and dense, on the Mohs scale of mineral hardness. Andesite ranks around 6.5, For comparison, iron is 4 to 5, bronze is 3. The tools available to the Tiwanaku should not have been hard enough to cut andesite efficiently. Yet the andesite blocks at Puma Punku are cut with precision that approaches modern machining standards. Flat surfaces are smooth and level to within hundredths of an inch. Right angles are truly perpendicular. Drill holes are perfectly circular and uniform in diameter. Some blocks have complex grooves and channels cut into them, creating shapes that interlock with other blocks in 3 dimensions. The H blocks are particularly striking. These are large stones shaped like the letter H when viewed from above, with straight channels cut through the center and precise notches at each end. The channels are flat-bottomed and uniform in width. The corners are sharp and clean. Some of these blocks weigh several tons, yet they're finished as if turned on a lathe. Other blocks show evidence of drilling. Circular holes penetrate the stone, their walls smooth and parallel. In some cases, the drill holes intersect at precise angles, suggesting either extraordinary skill or knowledge of geometry that allowed the masons to calculate where internal passages would meet. Modern stoneworkers have attempted to replicate these cuts using bronze tools and abrasives. The work is possible, but slow and labor-intensive. It requires constant resharpening of tools and enormous patience. The quarry where the andesite was sourced lies about 10 kilometers away across Lake Titicaca. Transporting 100-ton blocks across that distance and elevation would require sophisticated logistics. The Tiwanaku had llamas, which can carry modest loads but cannot pull wheeled carts. The wheel was not used for transport in pre-Columbian South America. Researchers have proposed various methods: wooden rollers, rope systems, earthen ramps. All are theoretically possible. None have been proven. Adding to the mystery is the site's current state. Puma Punku looks as if it was struck by catastrophe. The massive blocks are scattered, some toppled, others broken. The arrangement suggests a violent event rather than gradual decay. Was there an earthquake? A flood? Evidence of water erosion on some stones has led to speculation about massive flooding, though the Altiplano's current climate is too dry for such events. Climate change over the past millennium could explain wetter conditions in earlier periods. Dating Puma Punku has been contentious. Radiocarbon analysis of organic material found in the construction layers places the site between roughly 536 and 600 CE, consistent with the Tiwanaku culture's rise. But some researchers have argued for much earlier dates. In the early 20th century, Arthur Poznański, an Austrian engineer and archaeologist, proposed that Puma Punku was built around 15,000 BCE, based on astronomical alignments and geological interpretations. His dating has been thoroughly discredited by modern archaeology, but it persists in alternative literature. The current academic consensus dates Puma Punku to the 6th or 7th century CE, though some scholars acknowledge that earlier foundations may underlie the visible structures. This wouldn't be unusual. Many ancient sites were built in phases, with later cultures expanding or modifying earlier constructions. But without clear stratigraphic evidence, separating construction phases is difficult. The precision of the stonework invites speculation about lost technologies or advanced tools. Some alternative researchers propose that the Tiwanaku possessed cutting tools far more sophisticated than archaeology recognizes. Others suggest techniques involving sound waves, electromagnetic fields, or methods that soften stone temporarily. These theories lack supporting evidence and often contradict known physics. Mainstream archaeology offers more conservative explanations. The Tiwanaku were skilled stoneworkers who developed techniques through centuries of practice. They used copper and bronze tools, stone hammers, and abrasive sand to shape and polish andesite. The process was slow, but with enough labor and time, remarkable precision could be achieved. The blocks at Pumapunku may represent the pinnacle of their craft, showcasing the finest work their master masons could produce. Experimental archaeology supports this view. Researchers have successfully cut and shaped andesite using replica ancient tools. The work requires patience and constant tool maintenance, but it's achievable. What takes a modern mason hours with power tools might take ancient craftsmen weeks or months, but the results can be comparable. The key is not having superior tools, but having superior skill and unlimited time. Yet questions remain about specific features. The perfectly flat surfaces stretching across several square meters are difficult to explain. Achieving such flatness over large areas requires checking the surface constantly with straight edges and levels. Did the Tiwanaku possess such instruments? The uniform drill holes suggest either template-guided drilling or remarkable hand-eye coordination. The complex interlocking shapes require three-dimensional planning, visualizing how blocks will fit together before they're carved. There are intriguing details that complicate the picture. Some blocks show evidence of metal clamps or ties, with T-shaped grooves cut into adjacent stones. Similar clamps appear at other ancient sites, including Tiahuanaco proper, and even in ancient Greece. But at Pumapunku, some of these clamp holes are unfinished or misaligned, suggesting that the technique was being tested or refined rather than representing a perfected tradition. The scattered state of the site means that original arrangements are uncertain. Archaeologists have attempted reconstructions, but many blocks could fit in multiple locations. Without clear evidence of the original structure, we're left guessing at Pumapunku's appearance and function. Was it a temple, a palace, an administrative center? The precision suggests importance, but purpose remains elusive. The high-altitude location adds another dimension. At nearly 13,000 feet, working stone is physically demanding. The thin air makes labor exhausting. Modern visitors often experience altitude sickness. Yet the Tiwanaku not only worked here, but created some of their finest stonework in these conditions. That speaks to adaptation, physical conditioning, and cultural importance that outweighed practical difficulties. Comparison to other Andean sites shows both continuities and anomalies. At Sacsayhuaman, built by the Inca nearly 1,000 years later, polygonal masonry reaches similar levels of precision. At Ollantaytambo, massive stones are transported and fitted with care. This suggests that sophisticated stoneworking was a broader Andean tradition, not unique to Pumapunku. But Pumapunku's andesite work, especially the H-blocks and channel stones, stands out even within this tradition. The cultural context is important. The Tiwanaku were not primitive. They managed complex irrigation systems, supported large urban populations, and engaged in long-distance trade. Their ceramic show artistic sophistication. Their understanding of astronomy is evident in site alignments. In this context, advanced stoneworking is not impossible, it's expected. Elite classes in ancient societies often commissioned monumental works that showcase the limits of their civilization's capabilities. Still, the precision challenges assumptions. When engineers familiar with modern machining examine the Puma Punku blocks, they note tolerances that would be acceptable in contemporary construction. Surfaces that flat, angles that square, holes that circular. These are not crude approximations, but finished work that meets exacting standards, whether achieved through skill and patience or through techniques we haven't recognized. The result is undeniable. So how did Tawanaku stonemasons achieve precision that rivals modern milling machines? Were their techniques simply more sophisticated than we've credited? Did they possess tools that haven't survived or that we haven't recognized? Or does Puma Punku represent knowledge brought from somewhere else, another culture, another time, and then lost when Tiwanaku collapsed? The stones are testimony to incredible skill. But the workshops, the tools, the master craftsmen who passed down these techniques, all of that is gone. What remains are blocks that seem to mock our understanding of what Stone Age technology could achieve. Puma Punku's precision stones raise questions about lost techniques, but in Egypt, another mystery challenges not methods, but timelines. The Great Sphinx, guardian of the Giza Plateau, may be far older than anyone thought. The Great Sphinx of Giza is traditionally dated to around 2500 BCE, built during the reign of the pharaoh Khafre as a guardian of his pyramid. That's the orthodox timeline, accepted for more than a century. But in the 1990s, a Boston University geologist named Robert Schoch examined the weathering patterns on the Sphinx enclosure and reached a startling conclusion. The erosion, he argued, wasn't caused by wind and sand. It was caused by water, heavy, prolonged rainfall. The kind of rainfall Egypt hadn't seen since the end of the last ice age, around 9,000 to 7,000 BCE. If Schoch is right, the Sphinx is not 4,500 years old. It's more than twice that. Schoch's analysis began in 1990 when he was invited to examine the Sphinx by John Anthony West, an independent Egyptologist who had long argued for an earlier date. Schoch approached the question as a geologist, not an archaeologist, focusing on the physical weathering of the limestone rather than cultural or historical evidence. The Sphinx sits in an enclosure carved directly from the bedrock of the Giza Plateau. The enclosure walls, formed when the Sphinx was excavated, show distinct weathering patterns. Schoch observed vertical fissures and undulating surfaces on these walls, patterns he identified as consistent with water erosion rather than wind and sand. Wind-driven erosion, he noted, creates horizontal weathering, wearing away softer layers while leaving harder layers protruding. But the Sphinx enclosure shows vertical channeling, the kind produced by water running down surfaces during periods of heavy rainfall. For comparison, Schoch examined other structures at Giza, particularly the nearby Valley Temple and mortuary temples constructed during the same period as the pyramids. These structures, made from similar limestone and exposed to the same environment for the same duration, show primarily wind erosion. The contrast is striking. Why would the Sphinx and its enclosure show water erosion, while nearby contemporary structures show wind erosion? Schoch's conclusion was that the Sphinx must predate the other structures by thousands of years, having been exposed to rainfall during a much wetter climate period. The Sahara wasn't always desert. Between approximately 10,000 and 5,000 BCE, the region experienced what geologists call the African humid period. Monsoon patterns shifted northward, bringing regular rainfall to areas that are now bone dry. Lakes dotted the Sahara. Grasslands supported large animals. Rivers flowed where today there are only dry wadis. If the Sphinx was carved during this wet period, it would have been exposed to centuries or millennia of rainfall, explaining the water erosion patterns. As the climate dried and the Sahara expanded, the monument would have experienced increasing wind erosion, but the earlier water damage would remain as the dominant pattern. The implications are profound. If the Sphinx predates Khafre's reign by thousands of years, who built it? Egyptian civilization as we know it hadn't yet emerged in 7000 BCE. The Nile Valley was populated by Neolithic cultures, but they left no other evidence of monumental stone architecture. No temples, no palaces, no carved statuary. Yet according to Schoch's interpretation, these same people carved the largest stone sculpture in the ancient world. Egyptologists have pushed back forcefully. Mark Lehner, one of the foremost experts on Giza, argues that the erosion patterns can be explained without invoking extreme antiquity. The Sphinx has been buried in sand for much of its history, only its head visible above the dunes. When excavated and exposed, it would be subject to different weathering than structures that were never buried. Groundwater seeping through the limestone could create vertical weathering patterns without surface rainfall. Differential weathering, where varying hardness of limestone layers erodes at different rates, could produce the observed patterns. Zahi Hawass, former Egyptian Minister of Antiquities, has been particularly vocal in rejecting Schoch's dating. He points to the stylistic evidence. The Sphinx's face, though eroded, shows characteristics of Old Kingdom royal portraiture. The layout of the Giza complex, with the Sphinx positioned in relation to Khafre's Causeway and Valley Temple, suggests integrated planning, and most significantly, the Dream Stele, erected between the Sphinx's paws by Pharaoh Thutmose IV around 1400 BCE, refers to the Sphinx as an image of Khafre, though this interpretation of the damaged text is debated. Geologists have also challenged Schoch's analysis. Some argued that the weathering patterns he identified could result from the specific limestone's properties rather than climate. The Giza limestone varies in quality, with some layers more susceptible to erosion than others. Chemical weathering from dew, fog, and occasional modern rainfall could produce vertical channeling over thousands of years, even in a dry climate. The debate highlights a fundamental tension between different types of evidence. Schoch relies on geological observations that suggest Grey Age. Egyptologists rely on archaeological and historical context that place the Sphinx firmly in the Old Kingdom. Who's right depends partly on which evidence you prioritize. There are additional complications. The Sphinx has been repaired multiple times throughout history. Ancient Egyptians added stone blocks to restore eroded portions. Later cultures did the same. Modern conservation efforts have added more material. Distinguishing original weathering from later damage and repair is difficult. Some of what Shaw interpreted as ancient erosion might be more recent deterioration. The head of the Sphinx presents another puzzle. It's disproportionately small compared to the body, and it shows less erosion than the body and enclosure. Some have suggested the head was recarved in dynastic times, perhaps transforming an earlier, larger head into the face of Khafre. This would explain the stylistic features Egyptologists recognize while accounting for the body's greater weathering. But there's no direct evidence of recarving beyond the size disproportion. Climate data complicate the picture further. While the African humid period did bring wetter conditions to the Sahara, the Nile Valley itself may not have experienced the same dramatic increase in rainfall. Monsoon patterns are complex, and regional variations mean that increased precipitation in the central Sahara doesn't automatically translate to equally wet conditions on the Nile. The river valley has always had a different microclimate than surrounding areas. Shark himself has refined his position over the years. He now suggests the Sphinx core may date to 7,000 to 9,000 BCE, with later modifications and additions during dynastic times. This hybrid view attempts to reconcile geological observations with archaeological context, but it satisfies neither geologists who see clear water erosion, nor Egyptologists who see clear Old Kingdom construction. The absence of other monumental architecture from the proposed earlier period remains the strongest argument against Schoch's dating. If a culture capable of carving the Sphinx existed around 7,000 BCE, where are their other works? Why would they create one massive sculpture and nothing else? The conventional timeline places the Sphinx within a context of rapidly developing stone architecture, the pyramids, temples, and tombs of the Old Kingdom. Remove that context, and the Sphinx stands isolated and inexplicable. Yet the erosion patterns exist. They are observable, photographable, and subject to analysis. Geologists examining the Sphinx independently have reached varying conclusions. Some support Schoch's interpretation, others reject it. Still others suggest the patterns indicate greater complexity than either water-only or wind-only erosion, perhaps reflecting variable conditions over long periods. The controversy has persisted for more than 30 years without resolution. Academic conferences have been held, papers have been published, tours of the sites have been conducted with both Schoch and his critics present, examining the same stones and reaching opposite conclusions. That's not unusual in science. Competing interpretations often coexist until new evidence tips the balance. But in the case of the Sphinx, new evidence has been hard to come by. Non-invasive investigation methods could potentially resolve some questions. Ground-penetrating radar, seismic surveys, and core samples from the bedrock might reveal more about construction techniques and weathering patterns. But such investigations require permits from Egyptian authorities, and the site's cultural sensitivity makes destructive testing unlikely. We're left analyzing surface features that have been modified repeatedly over millennia. The Sphinx water erosion controversy remains unresolved in the eyes of some, settled science to others. Schoch's geological observations are real. The erosion patterns exist. But whether they indicate the Sphinx is 11,000 years old or simply reflect complex weathering processes over 4,500 years depends on which expert you ask. Without clear inscriptions or datable material from the original construction, we're left with inference and debate. If the Sphinx really is twice as old as the pharaohs, it would rewrite not just Egyptian history, but our entire understanding of when civilization began. That's a profound claim, and extraordinary claims, as they say, require extraordinary evidence. The Sphinx erosion debate centers on one monument. But flood myths, stories of catastrophic waters destroying earlier worlds, appear in cultures across the globe. Are these independent inventions, cultural diffusion, or memories of real events? In ancient Sumer, the gods decide to wipe out humanity with a great flood. One righteous man, Utnapishtim, builds a massive boat and survives. In the Hebrew Bible, God sends a deluge to cleanse the world, sparing only Noah and his ark. In Hindu texts, Manu is warned by a fish to build a vessel before the waters come. In Chinese mythology, Gun and his son Yu battle floods that threaten to destroy civilization. From the Greeks to the Maya, from Aboriginal Australia to Pacific Islands, flood myths appear in virtually every culture on Earth. The question has always been, why? More than 100 distinct flood myths have been documented across cultures with no apparent historical contact. They span continents and millennia, appearing in ancient Mesopotamia, pre-Columbian Americas, sub-Saharan Africa, and the islands of Oceania. The geographic distribution is so broad that it demands explanation. Either humanity independently invented the same catastrophic narrative dozens of times, or something happened that was remembered across multiple cultures. The oldest written flood narrative comes from Mesopotamia. The Epic of Gilgamesh, compiled around 2100 BCE, but drawing on earlier oral traditions, tells of Utnapishtim, who survived a divine flood that destroyed the world. The gods, disturbed by human noise, decide to send the deluge. But one god, Ea, warns Utnapishtim in a dream. He builds a cube-shaped ark, loads it with animals and craftsmen, and rides out the storm. After the waters recede, he releases birds to find dry land. The parallels to the later biblical account are obvious and have been the subject of scholarly debate for more than a century. The biblical flood narrative in Genesis follows a similar pattern. God sees human wickedness and decides to cleanse the earth. Noah, a righteous man, is warned to build an ark. He brings his family and pairs of animals aboard. The flood covers the earth for 40 days and nights. Eventually, the waters recede, and Noah releases a dove that returns with an olive branch, signaling the presence of dry land. God promises never to flood the earth again, marking the covenant with a rainbow. In Hindu tradition, Manu receives warning from a small fish he rescues. The fish grows enormous and reveals itself as the god Vishnu in disguise. It tells Manu to build a boat because a great flood will destroy all life. Manu follows the instructions, and when the deluge comes, the fish tows his boat to safety in the Himalayas. From there, humanity is reborn. The text is found in the Matsya Purana and other Hindu scriptures, with versions dating back at least 2,000 years. Chinese mythology preserves stories of catastrophic floods that required heroic intervention to control. The legendary figure, Gun, is tasked with controlling the waters, but fails, dying in the attempt. His son Yu succeeds, using dredging and engineering to channel the floods and make the land habitable again. Yu becomes a culture hero, eventually founding the Xia dynasty. While the narrative differs, focusing on flood, control rather than survival, the underlying theme of civilization threatening waters appears here as well. Greek mythology includes Deucalion and Pyrrha, who survive a flood sent by Zeus to punish humanity's wickedness. They build a wooden chest, float on the waters for 9 days, and eventually land on Mount Parnassus. After the flood, they repopulate the earth by throwing stones over their shoulders, which transform into people. The story appears in various Greek and Roman sources, including Ovid's Metamorphoses. The Maya have their own flood narrative in the Popol Vuh. The gods create humanity multiple times, destroying earlier versions that failed to worship properly. One destruction comes through flooding, wiping out the wooden people who inhabited the earth before the current human race. The surviving wooden people become monkeys, a reminder of the failed creation. Australian Aboriginal traditions contain stories of rising seas submerging coastal lands. Some describe times when people could walk to what are now islands. Others tell of great floods that reshaped the landscape. As discussed earlier, some of these stories correlate with geological evidence of post-Ice Age sea level rise, suggesting they preserve genuine memories reaching back thousands of years. Pacific Islander traditions across Polynesia and Melanesia include flood narratives. In Hawaiian mythology, the hero Nu'u builds a canoe to escape rising waters. In Fiji, a flood story mirrors the Ark narrative, with a man warned to build a boat to survive divine wrath. The distribution across isolated island cultures raises questions about whether these stories traveled with migrating peoples or developed independently. Common elements appear across these narratives with striking frequency. There's typically a divine decision to destroy humanity, often motivated by wickedness or excessive noise. A single righteous individual or family receives warning, usually from a sympathetic deity. They build a boat or seek high ground. The flood destroys the world, often covering the highest mountains. Birds are released to find land. Eventually, the waters recede, and the survivors repopulate the earth. In many versions, there's a divine promise or covenant not to repeat the destruction. Traditional anthropological explanations focus on universal human psychology. Floods are common natural disasters. Every culture living near water experiences flooding. Catastrophic local floods, rivers overflowing, storm surges, tsunamis sear themselves into cultural memory. Over generations, these local events are mythologized, exaggerated, and given cosmic significance. The similarity of flood myths, in this view, reflects similarity of human experience and storytelling patterns, rather than a single historical event. Some anthropologists also point to the psychological archetype of destruction and renewal. Flood myths often serve as origin stories, explaining not just catastrophe, but rebirth. They establish moral frameworks. The gods punish wickedness, but preserve the righteous. They explain why the world is as it is. These narrative functions appear across cultures because they address universal human concerns about justice, divine power, and the fragility of civilization. But there's another interpretation, one that draws on geology and climatology. At the end of the last ice age, between 15,000 and 7,000 years ago, global sea levels rose by approximately 400 feet. This wasn't a single event, but a long process with periodic, rapid pulses. The melting ice sheets released enormous quantities of water into the oceans, drowning coastlines where humans almost certainly lived. The drowning of these coastal areas would have been catastrophic for the people living there. In some regions, the sea advanced kilometers inland over centuries. In others, sudden meltwater pulses or coastal collapses caused rapid inundations. The Black Sea, for instance, may have experienced a dramatic flood around 5600 BCE, when Mediterranean waters broke through the Bosphorus, turning a freshwater lake into a saltwater sea. Geological evidence supports this scenario, though the scale and speed remain debated. If significant populations lived on now submerged continental shelves, and If those populations experienced the trauma of rising seas destroying their homelands, those events might have been preserved in oral tradition. Stories passed down through generations could eventually become the flood myths we see in ancient texts. The cosmic scale of the destruction would reflect the actual experience of watching the sea advance year after year, consuming familiar landscapes. This interpretation doesn't require a single global flood in the biblical sense. Instead, it proposes that post-Ice Age sea level rise created traumatic experiences in multiple coastal populations around the world. Each culture developed its own narrative to explain and memorialize the catastrophe. But the underlying reality, rising waters destroying inhabited land, was shared. Graham Hancock and other alternative researchers have proposed that these flood myths preserve memories of an advanced pre-Ice Age civilization destroyed by rising seas. In this view, stories like Atlantis represent garbled memories of real places drowned when sea levels rose. The theory is appealing, but faces the challenge of evidence. If advanced civilizations existed on now submerged shelves, we'd expect underwater archaeology to find traces, ruins, tools, ports. Some finds exist, but they're consistent with Neolithic coastal settlements, not advanced urban centers. The academic mainstream generally rejects the lost civilization interpretation while acknowledging that flood myths may contain kernels of historical memory. Local flooding events, tsunami, volcanic eruptions causing sea surges, and gradual post-Ice Age inundation all provided real experiences that could be preserved and mythologized. The challenge is distinguishing accurate memory from narrative embellishment. Climate science provides context. During the African humid period, Lake Megachad in North Africa covered an area larger than the Caspian Sea. When the climate shifted and the lake dried, populations around it would have experienced catastrophic loss of water resources. In the Mediterranean, the Zanclean flood around 5 million years ago refilled the entire basin through the Strait of Gibraltar. But that predates humans. More recent, but still prehistoric events include catastrophic glacial lake outbursts where ice dams holding back meltwater suddenly failed, sending walls of water across landscapes. Geological records confirm that catastrophic flooding has occurred throughout Earth's history. The channeled scablands in Washington state were carved by glacial lake floods of unimaginable power. The Mediterranean's history includes multiple desiccation and refilling events. But linking these geological events to specific cultural memories requires evidence that human populations witnessed them and passed down accounts. So do flood myths preserve memories of real catastrophes that destroyed earlier civilizations? Or are they simply what happens when every human culture lives near water and occasionally experiences devastating floods? The answer likely lies somewhere between. Yes, sea levels rose dramatically as the Ice Age ended, inundating coastlines where humans certainly lived. Yes, catastrophic local floods occur throughout history, searing themselves into cultural memory. But to leap from those facts to the existence of advanced global civilizations requires more than mythology. It requires evidence. And along the drowned coastlines of the world, that evidence may exist, waiting beneath 400 feet of water. Flood myths speak of lost worlds beneath the waves, but some of those worlds are real, and archaeology is beginning to find them. In Siberia, beneath permafrost and forest, structures are emerging that shouldn't exist. In 2008, Russian archaeologists excavating Denisova Cave in Siberia's Altai Mountains found a finger bone from a juvenile female. DNA analysis revealed something extraordinary. This was neither Homo sapiens nor Neanderthal, but a distinct human species, now called Denisovans. We know almost nothing about them. No complete skeleton, no clear physical description. But we know they made sophisticated stone tools, jewelry from animal bones, and a stone bracelet polished to a shine that required drilling techniques not expected for 40,000 years ago. And genetic analysis reveals that modern humans interbred with them, carrying their DNA into Asia and Oceania. What else did they build that we haven't found? Denisova Cave sits in the Altai Mountains, a remote region where Siberia, Mongolia, Kazakhstan, and China converge. The cave has been occupied intermittently for hundreds of thousands of years, serving as shelter for various human species. Excavations have uncovered layers of habitation stretching back more than 200,000 years, with evidence of Neanderthals, Denisovans, and modern humans all using the same space at different times and occasionally overlapping. The finger bone that revealed the Denisovans' existence was tiny, just the tip of a pinky finger from a child who lived approximately 50,000 years ago. When geneticists extracted DNA and sequenced it, they expected to find either Homo sapiens or Neanderthal. Instead, they found a genome distinct from both, though more closely related to Neanderthals than to us. Further excavations yielded a few teeth, and later part of a skull from a different site in Tibet. That's the entire physical record: a finger bone, some teeth, and skull fragments for an entire species of human. Yet those scraps of bone tell a remarkable story. Genetic analysis shows that Denisovans interbred with anatomically modern humans, probably multiple times in different regions. Today, people in Papua New Guinea, Aboriginal Australians, and other Oceanian populations carry Denisovan DNA, sometimes as much as 4 to 6% of their genome. That's a higher percentage than most Europeans carry of Neanderthal DNA. The Denisovans weren't a failed evolutionary branch. They were successful enough to spread across Asia and contribute significantly to modern human genetics. The artifacts found in Denisova Cave suggest capabilities beyond what we'd expect from archaic humans. Among the most striking is a chlorite bracelet dated to between 40 and 50,000 years ago. The bracelet is polished smooth and features a drilled hole, perfectly circular and uniform. Creating such a hole requires a drill bit rotating at high speed with consistent pressure. The polish suggests the stone was ground with fine abrasives, perhaps sand, and considerable skill. This isn't crude handiwork. It's craftsmanship. Other artifacts include bone needles with eyes for threading, implying the production of fitted clothing. Stone tools show sophisticated knapping techniques. Pendants and beads suggest personal ornamentation and possibly symbolic thinking. For decades, these capabilities were thought to be unique to Homo sapiens, emerging only with behavioral modernity around 50,000 years ago. The Denisovan artifacts push those capabilities back and extend them to a species we barely knew existed until 15 years ago. But the physical remains and artifacts are only part of the story. In recent years, controversial claims have emerged about possible Denisovan architecture. In the Shoria Mountains of southern Siberia, formations of massive stone blocks have been cited by alternative researchers as evidence of ancient megalithic construction. Videos and photographs show what appeared to be stacked stones forming walls and structures, some blocks weighing hundreds of tons. The Shaurya megaliths, as they're called, became internet sensations when images circulated showing enormous polygonal stones fitted together. To believers, they represent evidence of advanced, archaic human civilizations capable of moving and shaping massive stones, possibly built by Denisovans or their contemporaries. Some have drawn comparisons to Sacsayhuaman or other precision megalithic sites, arguing that similar construction techniques appear in Siberia. Mainstream geologists and archaeologists who've examined the Shaurya formations are nearly unanimous in their assessment. These are natural rock formations, not human constructions. The stones show characteristics of jointing and weathering patterns consistent with geological processes. Granite and other igneous rocks naturally fracture along planes of weakness, creating blocks that can appear hewn or stacked. Frost wedging, where water freezes and cracks and splits stone, can produce remarkably regular shapes. Erosion removes softer material, leaving harder blocks exposed in arrangements that look artificial. Similar misidentifications occur worldwide. The Giant's Causeway in Northern Ireland consists of hexagonal basalt columns that look manufactured but are entirely natural, formed by cooling lava. The Devil's Postpile in California shows similar columnar jointing. In each case, geological processes create patterns that seem too regular to be natural, yet they are. The Shaurya formations appear to fall into this category. No tool marks have been identified on the Shaurya stones. No evidence of quarrying, transport, or construction exists. No artifacts suggesting human activity in the area during the relevant time periods have been found. The formations lack the characteristics of actual megalithic construction. Precisely cut surfaces, intentional shaping, fitted joints designed to interlock. What they show instead are natural fracture patterns, weathering, and erosion. Yet the appeal of the megalith interpretation persists, partly because we know so little about the Denisovans. They were real. They were sophisticated. They survived in harsh Siberian environments for tens of thousands of years. What did they build? Where did they live? Without more evidence, the void is filled by speculation. Other claimed structures in the Ural Mountains have met similar skepticism. Stone walls reported by explorers and enthusiasts have been investigated and determined to be natural formations, or in some cases, relatively recent constructions by historical populations. The challenge with evaluating such claims is that remote regions often lack archaeological survey. Sites are proposed based on photographs or satellite imagery, rather than ground truthing by trained researchers. The deeper question is what could survive 40,000 years or more. In Siberia's climate, freeze-thaw cycles destroy most materials. Wood rots or burns. Organic materials decay. Even stone structures would be subject to severe weathering. Anything the Denisovans built from perishable materials, and Paleolithic peoples built extensively with wood, bone, and hide, would be gone. Only stone would endure, and only if the construction was substantial enough to withstand tens of thousands of winters. Compare this to what we know from well-documented Paleolithic sites. In Europe, Neanderthals and early modern humans built structures from mammoth bones, wood, and hides. We know this because rare preservation conditions, burial in sediment, saturation in peat, protected the remains. But such conditions are exceptional. For every preserved site, hundreds or thousands must have existed and left no trace. If Denisovans built similar structures, we'd expect to find almost nothing after 40,000 years. What does survive provides hints. The Denisovan bracelet indicates aesthetic sensibility and technical skill. The bone needles suggest cold-adapted clothing. The diverse diet, evidenced by isotopic analysis of their remains, shows they exploited a range of food sources. They were not primitive, but sophisticated tools and personal ornaments don't equate to monumental architecture. The leap from jewelry to megalithic construction requires evidence that doesn't exist. Genetic research continues to expand our understanding. In 2018, analysis of a bone fragment revealed a girl whose mother was Neanderthal and father was Denisovan, direct evidence of interbreeding between archaic human species. In 2019, a jawbone found on the Tibetan Plateau pushed Denisovan habitation to high altitudes and extended their range far beyond the Altai Mountains. Each new find adds detail, but the overall picture remains frustratingly incomplete. The Denisovans are ghosts in our genome, present but barely visible. They made art, tools, and jewelry with surprising sophistication. They lived in Siberia for tens of thousands of years, adapting to one of Earth's harshest environments. And then they vanished, leaving almost nothing behind except traces of DNA and a handful of artifacts. If a human species that successful can disappear so completely, leaving us almost no evidence of their existence, what does that say about our ability to find evidence of other lost cultures? How much could vanish in 40,000 years or 100,000? Denisovans lived in the deep past, but even within the time frame of modern humans, entire cities have been swallowed by rising seas. Along coastlines worldwide, evidence of lost settlements is emerging from beneath the waves. When the last ice age ended around 11,700 years ago, sea levels were 400 feet lower than today. What is now the Mediterranean coastline extended miles further out. The Black Sea was a freshwater lake. The Persian Gulf was a river valley. The English Channel was dry land connecting Britain to Europe. Across the world, continental shelves that today lie beneath 200 feet of water were exposed plains, river valleys, and coastlines. Exactly the kind of landscape humans prefer for settlement. As the ice melted, those landscapes drowned, and with them went whatever evidence of human habitation they held. The process wasn't instantaneous. Sea level rise occurred over thousands of years, though the rate varied. Some periods saw rapid pulses when ice dams failed and meltwater surged into the oceans. Other periods experienced slower, steadier rises as glaciers gradually melted. But the cumulative effect was enormous. An estimated 20 million square kilometers of land, an area larger than Russia, was submerged as the oceans reclaimed the continental shelves. Continental shelves are geologically part of continents, not ocean basins. They're shallow underwater extensions of land masses, typically sloping gently from the coastline to depths of about 200 meters, before dropping off more steeply. During glacial periods, when seawater is locked up in ice sheets, these shelves are exposed as dry land, and they're prime real estate for human settlement, flat, coastal, with access to both marine and terrestrial resources. Archaeological logic suggests that if humans were present during the Ice Age, they would have lived preferentially on these now submerged lands. Coastal zones offer abundant food: fish, shellfish, seabirds, marine mammals. Along with freshwater from rivers and streams, they provide transportation routes via boats, and they tend to have milder climates than inland regions. For hunter-gatherers and early farmers alike, coastlines are attractive settlement locations. The best documented example of a drowned landscape is Doggerland, which we'll examine in more detail shortly. But Doggerland is just one of many submerged lands. In Southeast Asia, an area called Sundaland connected the Malay Peninsula to Sumatra, Java, and Borneo. At its maximum extent during the last glacial maximum around 20,000 years ago, Sundaland was nearly twice the size of modern India. It was crisscrossed by rivers, supported extensive forests and grasslands, and almost certainly harbored substantial human populations. Beringia, the land bridge connecting Asia to North America, is another drowned landscape. For thousands of years, it was not a narrow isthmus, but a broad plain hundreds of miles wide. The first Americans crossed Beringia on foot, following game and exploring new territories. When sea levels rose, the bridge disappeared, separating the Americas from Asia and isolating populations on either side. Around Australia and New Guinea, the Sahel continental shelf was exposed during the Ice Age. The two landmasses were connected, along with Tasmania, forming a single continent called Sahel. Aboriginal peoples spread across this expanded landscape, and rising seas eventually cut Tasmania and New Guinea off from mainland Australia. Archaeological sites that document this early habitation now lie underwater. In the Mediterranean, the Adriatic Sea was largely dry land during glacial periods. Rivers flowed across what is now the sea floor, and early Europeans would have hunted and foraged in areas that today are beneath 100 meters of water. Similar scenarios played out in the North Sea, the Persian Gulf, the Gulf of Thailand, and countless other regions where shallow seas now cover what were once plains and valleys. Some submerged settlements have been found and studied. Off the coast of India near Gujarat, the legendary city of Dwarka has been located underwater. According to Hindu texts, Dwarka was the capital of Lord Krishna and was submerged by the sea after his death. Marine archaeology has revealed stone structures, walls, and artifacts at depths of up to 40 meters. The site dates to roughly 1500 BCE, much more recent than the Ice Age inundations, but proof that cities can indeed be drowned and then rediscovered millennia later. Pavlopetri, off the coast of southern Greece, is another example. This Bronze Age settlement, dating to around 3000 BCE, lies in shallow water and includes buildings, streets, and tombs. It's one of the oldest known submerged cities, preserved because it sank gradually rather than being destroyed catastrophically. The layout is clearly visible underwater, offering a rare glimpse of an ancient town plan. Herakleion, an Egyptian city mentioned in ancient texts, was lost for more than 1,000 years before being rediscovered in 2000 off the coast of Alexandria. The city sank sometime in the 8th century CE, possibly due to earthquakes and soil liquefaction. Underwater excavations have revealed temples, statues, and inscriptions, dramatically confirming that major urban centers can vanish beneath the waves and be completely forgotten. Yonaguni, off the coast of Japan, presents a more controversial case. A formation of stepped stone structures was discovered in the 1980s and has been championed by some as an ancient submerged city or temple complex, possibly 10,000 years old or more. However, most geologists who have examined the site conclude that the features are natural, the result of wave action and erosion on horizontally bedded sandstone that naturally fractures into block-like shapes. While intriguing, Yonaguni more likely represents the human tendency to see patterns and intention in natural formations. The distinction between genuine submerged settlements and natural formations is critical. Underwater archaeology faces significant challenges. Visibility can be poor. Currents and sediment make excavation difficult, and biological activity, marine borers, algae, coral growth can obscure or destroy features. Still, actual human structures leave recognizable traces, tool marks on stones, regular building patterns, associated artifacts like pottery or tools, and the presence of clearly worked materials all distinguish human construction from natural formations. What can survive underwater depends on materials and conditions. Stone, foundations and structures can endure millennia if conditions are right. Ceramics are durable. Metals corrode but can leave recognizable forms. Wood can survive in anaerobic conditions where oxygen levels are too low for decay organisms. But organic materials like textiles, leather, and rope typically vanish unless preservation is exceptional. The challenge is scale. Millions of square kilometers of potential settlement area are now underwater. Only a tiny fraction has been surveyed. Underwater archaeology is expensive, time-consuming, and requires specialized equipment and training. Most projects focus on known shipwrecks or sites identified through historical records. Systematically surveying vast submerged plains for prehistoric settlements is beyond current capabilities. Technology is improving. Side-scan sonar can map large areas of seafloor relatively quickly. Multi-beam bathymetry creates detailed topographic maps of underwater landscapes. Remotely operated vehicles equipped with cameras can investigate features without sending divers down. An analysis of sediment cores can reveal pollen, charcoal, and other signs of human activity on now submerged landscapes. Recent surveys have identified potential archaeological features on various continental shelves. Off the coast of Denmark, divers have found remnants of Mesolithic settlements, including wooden fish traps and stone tools. In the North Sea, trawlers occasionally bring up artifacts, flint tools, bone points, even fragments of worked wood that prove human habitation. Each find confirms what logic suggests. People lived on the exposed shelves during the Ice Age. But how sophisticated were these coastal settlements? That's harder to determine. The finds so far suggest hunter-gatherer populations consistent with the Mesolithic period. Stone tools, fishing equipment, and simple structures are what we'd expect. There's no evidence yet of cities, agriculture, or advanced architecture on the drowned shelves. That doesn't mean such evidence doesn't exist, only that we haven't found it. If advanced settlements did exist on now submerged coastlines, several factors would make them hard to detect. First, they'd be covered by centuries of marine sediment. Second, the most developed areas would have been along river mouths and harbors, exactly the places where sediment deposition is heaviest. Third, rising seas would have subjected structures to wave action during inundation, potentially destroying all but the most solid foundations. And fourth, with limited survey coverage, we might simply not be looking in the right places. The implications are sobering. If we estimate conservatively that even 1% of human habitation occurred on now submerged lands. That's millions of potential archaeological sites we cannot easily access. The record of human prehistory is incomplete, not because early humans left no trace, but because much of where they lived is now underwater. Visualize it from above. Before the seas rose, coastlines stretched kilometers further out. River deltas extended into what are now open waters. Islands that today are separated were connected by land bridges. Then watch the simulation run forward. The ice melts. The seas creep inland year by year, century by century. Coastal villages are abandoned as inhabitants retreat before the advancing waters. Everything left behind is submerged, buried, scattered. When the seas finally stabilize at modern levels, the old coastlines lie far offshore, deep beneath the waves. So how many settlements lie beneath the waves? How many early experiments in agriculture, architecture, and social organization were drowned when the ice melted? We'll never know the full extent. Underwater archaeology is difficult, expensive, and covers only a tiny fraction of submerged continental shelves. But every new discovery, a stone foundation, a pottery shard, a worked piece of wood, proves that humans did live on those now drowned lands. What they built, how they lived, what they knew, most of that information is gone, erased by 400 feet of seawater. The ocean is a vast archive, and it's mostly unread. If rising seas erased coastal settlements, then oral traditions might be our only link to those lost worlds. Among the world's oldest continuing cultures, Aboriginal Australians possess stories that may encode memories reaching back 10,000 years or more. Aboriginal Australians have lived on their continent for at least 65,000 years, making their culture the world's oldest continuous civilization. Their oral traditions, passed through countless generations, contain stories about the Dreamtime, the creation period when ancestral beings shaped the land. For a long time, scholars treated these as purely mythological. Then geologists and anthropologists began comparing Dreamtime stories to geological records. Some stories describe coastlines that haven't existed for 10,000 years. Others mention megafauna, like the Diprotodon, a giant wombat-like creature that went extinct 45,000 years ago. The Dreamtime stories, it turns out, may be among the longest-running historical records on Earth. Archaeological evidence confirms human presence in Australia for at least 65,000 years, based on findings at Majid Bebe Rock Shelter in the Northern Territory. Stone tools, ochre, and other artifacts from the lowest layers radiocarbon date to this period, pushing back the timeline of Aboriginal occupation and demonstrating that modern humans reached Australia far earlier than previously thought. Over those 65 millennia, Aboriginal cultures developed sophisticated knowledge systems encoded in oral traditions. The Dreamtime encompasses creation narratives, law, social organization, and practical knowledge about the landscape, plants, animals, and seasonal patterns. This knowledge was preserved through song, story, dance, and ceremony, passed from elders to younger generations with remarkable fidelity. What makes this preservation remarkable is that it occurred without writing. Information had to be memorized, performed, and transmitted orally. Yet recent research suggests that some Aboriginal traditions preserve accurate descriptions of landscape features and events from 10,000 years ago or more, a span of time that encompasses hundreds of generations. Geologist Patrick Nunn has spent years documenting Aboriginal oral traditions that correlate with verifiable geological events. One example comes from Port Phillip Bay in southeastern Australia. Aboriginal stories describe a time when the bay was dry land with freshwater streams where people hunted kangaroos. Geological evidence confirms that Port Phillip Bay was indeed a plain during the Ice Age, not flooding until approximately 9,000 years ago as sea levels rose. The Aboriginal accounts match the geological timeline with surprising accuracy. Similar stories appear around Spencer Gulf in South Australia. Dreamtime narratives describe when the Gulf was dry land that people walked across. Geological reconstructions show that Spencer Gulf was a valley rather than a marine inlet until roughly 12,000 years ago. Again, the oral traditions align with the physical evidence. Along the Queensland coast, Aboriginal traditions speak of times when the Great Barrier Reef Islands were connected to the mainland, and when certain reefs were hills above water. These descriptions match periods when sea levels were lower and the continental shelf was exposed. The flooding of these areas occurred between 10 and 12,000 years ago. Even more intriguing are references to now submerged features. Stories from the Tiwi Islands describe lands that once connected the islands to mainland Australia. Bathymetric surveys confirm that shallow areas between the islands would have been exposed during lower sea levels. The traditions preserve knowledge of a landscape that disappeared beneath the sea thousands of years before European contact. The mechanisms of preservation help explain this longevity. Aboriginal cultures treat certain knowledge as sacred and essential for survival. Dreamtime stories aren't entertainment, they're lore, science, and history combined. Elders are responsible for ensuring accurate transmission. Mistakes in recitation can be corrected by other knowledge holders. The social importance of getting the stories right creates strong incentives for accuracy. Songlines represent another form of encoded knowledge. These are routes across the landscape preserved in songs that describe features, resources, and sacred sites. A person singing their songline can navigate hundreds of kilometers using the song as a map. The landscape itself serves as a mnemonic device, anchoring abstract knowledge to physical locations. This interconnection of place and story may help explain why geographical memories persist so long. There are references to extinct megafauna in some oral traditions as well, though these are more difficult to verify. Aboriginal stories mention large animals that don't match any living species. Some researchers have suggested these could be memories of the Diprotodon, giant kangaroos, or the marsupial lion, all of which went extinct between 45 and 40,000 years ago. If these interpretations are correct, they would represent the oldest oral traditions in existence. Academic research into these correlations has gained momentum in recent years. Linguist and geographer Patrick Nunn has published extensively on Aboriginal sea level memories, documenting dozens of stories from around the Australian coast that describe landscapes now underwater. His work demonstrates systematic patterns. Coastal Aboriginal groups across Australia possess stories of lower sea levels, drowned lands, and rising waters. The consistency across geographically separated groups suggests independent preservation of genuine memories rather than recent invention or cultural borrowing. Lynette Russell, an Australian historian and anthropologist, has also explored how Aboriginal oral traditions preserve historical information. Her research emphasizes the sophistication of Aboriginal knowledge systems and cautions against dismissing oral traditions as mere mythology when they often contain practical and historical truth. The implications extend beyond Australia. If oral traditions can accurately preserve geographic information for 10,000 years, what about other cultures? Polynesian traditions include detailed navigation knowledge and stories of migrations across the Pacific. These have been validated by archaeology and genetics. Celtic oral traditions preserved historical events later confirmed by Roman written accounts. Andean peoples maintained quipu, knotted string records, alongside oral histories that stretched back centuries. The question becomes, what knowledge has been lost when oral traditions were broken? Colonialism, disease, and cultural suppression destroyed countless oral traditions worldwide. Languages went extinct, taking their stories with them. Elders died before passing on knowledge. Forced assimilation disrupted transmission. The loss is incalculable. In North America, indigenous oral traditions describe megafauna, volcanic eruptions, and landscape changes. Some of these have been correlated with geological events from thousands of years ago. The Klamath people of the Pacific Northwest have stories of the creation of Crater Lake that accurately describe the volcanic eruption of Mount Mazama 7,700 years ago. The details match the geological sequence: a mountain that exploded, ash falling like snow, and a lake forming in the caldera. Maori traditions in New Zealand preserve memories of volcanic eruptions, earthquakes, and the arrival of their ancestors by canoe from Polynesia. These traditions, maintained through Huakapapa genealogies and oral recitation, have been confirmed by archaeology and volcanic chronologies. What makes Aboriginal traditions particularly valuable is their extreme age and continuity. Unlike cultures that were conquered, replaced, or dramatically transformed, Aboriginal societies maintained cultural continuity for tens of thousands of years. That continuity allowed knowledge to be preserved across timescales that other cultures couldn't match. The methods of transmission deserve attention. Stories were not told casually but performed in ceremonial contexts with specific purposes. Some knowledge was restricted, shared only with initiated individuals who had earned the right to know. This selectivity ensured that crucial information was treated seriously and transmitted accurately. Young people learned through immersion, hearing stories repeatedly until they could recite them perfectly. The landscape itself reinforced memory. Sites mentioned in stories could be visited. Features described could be seen and touched. This grounding in physical reality prevented abstract drift. When a story says that ancestors hunted kangaroos where Port Phillip Bay now stands, the bay itself is a constant reminder of the story's content. Modern Aboriginal communities continue to maintain these traditions, though the impact of colonization has been severe. Many languages have been lost, taking their unique stories with them. But efforts to preserve and revitalize Aboriginal languages and knowledge are underway, recognizing the value of what has survived. For the question of lost civilizations, Aboriginal oral tradition offers both hope and caution. Hope because it proves that human memory, when carefully preserved through ritual and repetition, can reach back astonishing distances in time. If stories about coastlines can survive 10,000 years, then perhaps other traditions from other cultures now gone, once encoded knowledge we can no longer access. But caution because it demonstrates what's required for such preservation: unbroken cultural continuity, social structures that prioritize accurate transmission, and the absence of catastrophic disruption. Break that chain through disaster, conquest, or demographic collapse, and the knowledge vanishes as if it never existed. Aboriginal oral tradition proves that human memory, when carefully preserved through ritual and repetition, can reach back astonishing distances in time. If stories about coastlines can survive 10,000 years, then perhaps other traditions from other cultures now gone, once encoded knowledge we can no longer access. When a civilization disappears without writing, everything it knows must be carried in memory and song. And when those memories fade, when the singers die, when the stories are forgotten, entire worlds of knowledge can vanish as completely as if they never existed. Aboriginal memory spans 65,000 years. But there was a moment, much deeper in the past, when modern human populations crashed to a tiny remnant, an event that may have erased whole branches of human development. 74,000 years ago, the island of Sumatra exploded. The Toba supervolcano, in one of the largest eruptions in Earth's history, ejected 2,800 cubic kilometers of ash into the atmosphere. The explosion was heard across continents. Volcanic winter followed, with global temperatures dropping by 3 to 5 degrees Celsius for years, possibly decades. Genetic evidence suggests that human populations crashed during this period, perhaps to as few as 3,000 to 10,000 breeding individuals worldwide. We came within a razor's edge of extinction, and any knowledge, any achievements, any cultures that existed before Toba had almost no chance of being passed on. The Toba eruption, technically classified as a VEI 8 event, the highest category on the Volcanic Explosivity Index, represents a scale of catastrophe difficult to comprehend. For comparison, the 1815 eruption of Mount Tambora, which caused the year without summer and widespread famine, was a VEI 7. Krakatoa in 1883 was VEI 6. Toba was an order of magnitude larger than these historical eruptions that caused global disruptions. It was, quite possibly, the most violent volcanic event to occur during the existence of anatomically modern humans. Geological evidence for the eruption is unambiguous. Ash layers from Toba have been identified across South Asia, into the Indian Ocean, and even as far as East Africa. Ice cores from Greenland show sulfate spikes consistent with massive volcanic injection of aerosols into the stratosphere. The eruption created Lake Toba, a crater lake that today measures 100 kilometers long and 30 kilometers wide, among the largest volcanic calderas on Earth. The climatic effects would have been catastrophic. Sulfur dioxide and ash ejected into the stratosphere would have formed a veil blocking sunlight, causing temperatures to plummet. Modeling suggests that global temperatures could have dropped by 3 to 5 degrees Celsius, with even more severe cooling in some regions. Growing seasons would have shortened dramatically. Tropical forests could have contracted. Water sources might have dried up as precipitation patterns shifted. For human populations already living on the edge of survival, these changes would have been devastating. The genetic evidence for a population bottleneck comes from studies of human DNA diversity. When geneticists analyze the variation in human genomes, they find remarkably low diversity compared to other large mammal species. Chimpanzees, despite having much smaller populations today, show greater genetic variation. This suggests that at some point in our past, human populations went through a severe constriction. a bottleneck where most lineages died out, leaving only a small founding population from which all modern humans descend. The timing of this bottleneck, estimated from molecular clock calculations, aligns roughly with the Toba eruption. Different studies place the bottleneck between 50 and 100,000 years ago, with 74,000 years falling within that range. The correlation is suggestive. A massive volcanic eruption occurs, climate collapses, and human genetic diversity crashes. Causa and effect seem clear. However, the link between Toba and the bottleneck has been challenged. Some geneticists argue that the bottleneck was less severe than initially proposed, affecting regional populations, but not reducing humanity to a few thousand individuals globally. Others suggest the bottleneck occurred gradually over tens of thousands of years, rather than as a sudden event. And archaeological evidence from India and Africa shows continued human occupation through the period, suggesting that at least some populations survived and maintained their cultures. Stone tool assemblages from sites in India, dated to around 74,000 years ago, show continuity across the Toba ash layer. The same tool types appear above and below the tephra, suggesting that whoever made them survived the eruption without dramatic cultural disruption. In Africa, Middle Stone Age sites also show continuity through this period. If Toba caused a near extinction event, we might expect to see major breaks in the archaeological record. The fact that we don't has led some researchers to question whether Toba's impact was truly as severe as the genetic models suggest. One possibility is that the bottleneck was regional rather than global. If most of the human population lived in Africa and southern Asia, the regions most affected by Toba, their populations could have crashed, while smaller groups in more distant regions survived relatively unscathed. Over time, descendants of the survivors repopulated the affected areas, and the genetic signature reflects this founding effect rather than near total extinction. Another complication is the nature of genetic bottlenecks themselves. A bottleneck doesn't require a catastrophic event. It can result from population structure, where small groups remain isolated from each other for long periods. Or it can reflect the success of a particular lineage that expands rapidly while others decline. Teasing apart these scenarios from genetic data alone is challenging. Still, the archaeological record around 74,000 years ago shows a gap in many regions. Sites are fewer, artifacts are scarcer. Whether this reflects actual population decline or simply poor preservation and limited survey is debated, but the pattern is consistent with a period of stress. The implications for human knowledge are profound. If populations did crash to a few thousand individuals scattered across Africa and possibly southern Asia, the cultural diversity that existed before would have been drastically reduced. Languages would have been lost. Technologies might have disappeared. Regional traditions and knowledge systems would have vanished with the groups that maintain them. Imagine the bottleneck, not in genetic terms, but in cultural ones. 74,000 years ago, modern humans had been around for at least 100,000 years, possibly longer. They had spread across Africa and into the Middle East. Different groups had adapted to different environments: coasts, savannas, forests, highlands, each developing specialized knowledge about their landscapes. Then Toba erupts, volcanic winter sets in, and populations crash. Most groups die out. Only a few survive, carrying with them only the knowledge their particular ancestors possessed. All the other branches of human culture, all the unique adaptations and innovations are erased. This is speculative, of course. We don't know what cultural diversity existed before Toba or how much was lost, but we do know that survival in extreme conditions favors certain traits: adaptability, generalized skills, the ability to exploit marginal resources, specialized knowledge, the kind that makes you expert in one particular environment or technique, can be a liability when conditions change dramatically. The survivors might have been the generalists, not the specialists, and with the specialists would have gone their specialized knowledge. Other species show evidence of population stress around the same time. Some genetic studies of chimpanzees, orangutans, and other mammals suggest bottlenecks during this period as well, supporting the idea that Toba caused widespread ecological disruption. If large mammals with diverse diets and wide ranges suffered, small human populations relying on specific food sources would have been even more vulnerable. There are details that make the scenario more vivid. Ash from Toba formed layers several meters thick in parts of India. Anyone caught in the ashfall would have died. Breathing the ash causes respiratory failure. Water sources contaminated with ash become undrinkable. Crops are buried. Animals flee or die. Survivors would have had to retreat from affected regions, crowding into areas where resources were already stretched. The volcanic winter that followed would have made recovery difficult. Even after the initial ashfall settled, sulfate aerosols in the stratosphere would have reduced sunlight for years. Temperatures would have remained depressed. Growing seasons would have been unreliable. Hunting would have become harder as animal populations declined. Coastal populations might have fared better, with marine resources providing a buffer, but inland groups would have faced famine conditions. Archaeological sites in East Africa show a gap in occupation around this time at some locations. Whether this represents actual abandonment or simply happens to be a period we haven't found sites for is unclear. But the possibility that Toba created regional depopulation events is real. The lesson from Toba, whether the bottleneck was as severe as some models suggest or less dramatic, is that humanity is vulnerable. Catastrophes can strike with little warning and erase not just lives, but entire lineages of human knowledge and culture. If any groups of Homo sapiens 74,000 years ago had developed sophisticated cultures, complex technologies, or unique knowledge systems, Toba likely erased them. And genetic evidence suggests that almost all humans alive today descend from the tiny population that survived. The rest, whoever they were, whatever they knew, is gone. Whether the Toba eruption reduced humanity to just a few thousand survivors or simply created regional population crashes, the lesson is clear. We are fragile. Catastrophes can strike with little warning and erase not just lives, but entire lineages of human knowledge and culture. And that fragility extends not just backward to our ancestors, but forward to us. Our own accumulated knowledge, for all its apparent solidity, rests on foundations that disasters could shatter. The Toba bottleneck shows how disasters can erase knowledge. But there's another mystery in human genetics, one that suggests all humans alive today share a recent common female ancestor, a woman who lived in Africa perhaps 150,000 to 200,000 years ago. Who was mitochondrial Eve, And what happened to her contemporaries? Every human alive today, all 8 billion of us, carries mitochondrial DNA inherited from a woman who lived in Africa roughly 150,000 to 200,000 years ago. Geneticists call her mitochondrial Eve. She wasn't the only woman alive at the time, not even the first woman. But through the accidents of history, disease, disaster, chance, she's the only one whose direct maternal lineage survives to the present. Similarly, all men alive today carry a Y chromosome that traces back to one man, Y chromosomal Adam, who lived perhaps 200,000 to 300,000 years ago. What happened to everyone else? The concept of mitochondrial Eve is often misunderstood. She wasn't the first human woman or the only woman of her generation. She's simply the most recent common matrilineal ancestor of all living humans. Think of it this way. Everyone has a mother, and that mother had a mother, and so on back through time. If you could trace everyone's maternal lineage backward, eventually all those lines would converge on a single woman who lived in Africa between 150,000 and 200,000 years ago. That's mitochondrial Eve. The reason we can identify her is mitochondrial DNA. Unlike nuclear DNA, which shuffles and recombines with each generation, mitochondrial DNA is inherited only from mothers and passes down relatively unchanged except for random mutations. By comparing the mitochondrial DNA of people alive today and calculating mutation rates, geneticists can work backward to estimate when the most recent common ancestor lived. Y chromosomal Adam works the same way but through the male line. Men inherit their Y chromosome from their fathers, and it passes down with minimal recombination. By analyzing Y chromosomes across populations, researchers have determined that all men alive today share a common patrilineal ancestor who lived roughly 200,000 to 300,000 years ago. Interestingly, he lived more recently than some estimates for the mitochondrial DNA ancestor, though dating uncertainties mean the two could have been contemporaries. These are not the same as the first humans, or even the first Homo sapiens. Anatomically, modern humans existed well before mitochondrial Eve. She was simply a woman living in a population of modern humans in Africa, and by demographic luck, her maternal line outlasted all others. Other women who lived at the same time may have had descendants, but their direct maternal lines eventually died out. Perhaps they had only sons, or their daughters had only sons, or their lineages simply went extinct in the random fluctuations of small populations. The statistical nature of lineage survival is crucial. In small populations, genetic drift, random changes in gene frequencies, can eliminate lineages even without selective pressure. Imagine a village of 100 people. Some families have many children, others have few. Some lineages expand, while others contract. Over many generations, most original lineages will disappear, leaving only a few founding lines. Scale this up to ancient Africa with scattered populations, and you see how one woman's maternal line could eventually become the only one that survives. Bottleneck events accelerate this process. When populations crash due to climate change, disease, or disaster, many lineages are lost simply because the individuals carrying them die. The Toba eruption, if it caused the bottleneck, some geneticists propose, would have eliminated countless genetic lineages. The survivors would carry only a subset of the genetic diversity that existed before. As those survivors' descendants repopulated the world, they would carry forward only the lineages that made it through the bottleneck. The dates for mitochondrial Eve and Y chromosomal Adam aren't precise. They're estimates based on mutation rates, which can vary and aren't perfectly calibrated. Some studies place mitochondrial Eve at 150,000 years ago. Others suggest closer to 200,000. Y chromosomal Adam's date is similarly uncertain, with estimates ranging from 200,000 to 300,000 years ago. The uncertainty reflects both the difficulty of measuring mutation rates and the complexity of ancient population structures. What's clear is that lineages go extinct. Most people who lived in the past have no living descendants today. Their family lines died out somewhere along the way. This happens constantly, even in modern populations. Surnames disappear when families have no sons to carry them forward. Entire clans vanish when wars, famines, or plagues wipe them out. Scale this over hundreds of thousands of years, and the winnowing effect is dramatic. The implications for human diversity are profound. If all humans today trace their maternal lineage to one woman and their patrilineal descent to one man, that means countless other lineages, other branches of the human family tree, have disappeared. With them went their unique genetic variations, their accumulated adaptations, and potentially their cultural innovations. We can't know what those lost lineages contributed to human diversity because they're gone, leaving no trace except in the mathematical inference of their absence. Interestingly, this doesn't mean all ancient DNA is lost. Neanderthals, who went extinct roughly 40,000 years ago, left genetic contributions in modern humans. Most people of European and Asian descent carry roughly 2% Neanderthal DNA. This DNA entered our lineage through interbreeding. Modern humans and Neanderthals produced viable offspring whose descendants are ours. Similarly, Denisovans contributed DNA to modern populations in Asia and Oceania, sometimes as much as 4 to 6% in Melanesian and Aboriginal Australian populations. These archaic admixtures complicate the picture. While our direct maternal and patrilineal lines trace to specific individuals in Africa, our overall genome is a mosaic that includes fragments from Neanderthals, Denisovans, and possibly other archaic humans we haven't yet identified. These fragments survived because they provided adaptive advantages, genes for immune function, high-altitude adaptation, and other traits that helped modern humans survive in new environments. Recent research continues to refine our understanding. In 2019, a study suggested that mitochondrial Eve might have lived more recently than previously thought, perhaps only 100,000 years ago. Other studies have identified additional structure in human population history, suggesting periods of isolation and reconnection between African populations. The tree of human ancestry is more complex than a simple branching diagram, with populations splitting, merging, and exchanging genes in patterns that genetic analysis is only beginning to untangle. What this means for lost civilizations is subtle but important. Mitochondrial Eve and Y chromosomal Adam demonstrate that survival is not guaranteed, not for individuals, not for families, not even for entire genetic lineages. Over 200,000 years, countless branches of the human family tree have died out, leaving no genetic trace. With them went their unique experiences, their cultural innovations, their accumulated knowledge. Genetics can show us that they existed, but it cannot tell us what they knew or what they built. Population genetics reveals another layer of mystery. Some populations show evidence of ancient structure, long periods of separation followed by reconnection. African populations in particular show high genetic diversity consistent with multiple lineages evolving in relative isolation before coming back into contact. What cultures developed during those periods of isolation? What knowledge systems emerged and then merged, or were lost when populations reconnected? We have no way to know. The concept also highlights how demographic chance shapes history. Mitochondrial Eve wasn't special in any biological sense. She wasn't smarter, stronger, or more fit than her contemporaries. She was simply lucky. Her daughters had daughters, generation after generation, and everyone else's maternal lines eventually died out. Success in evolution and history often comes down to chance as much as capability. For the question of lost knowledge, this matters. If lineages carrying specific cultural traditions died out, their knowledge died with them. A family that specialized in crafting stone tools, a clan that knew medicinal plants, a community that preserved astronomical observations, all could vanish if their lineage went extinct. No genes, no descendants, no memory. Mitochondrial Eve and Y-chromosomal Adam remind us that survival is not guaranteed, not for individuals, not for families, not even for entire genetic lineages. Over 200,000 years, countless branches of the human family tree have died out, leaving no genetic trace. With them went their unique experiences, their cultural innovations, their accumulated knowledge. Genetics can show us that they existed, but it cannot tell us what they knew or what they built. For that, we need archaeology, and in the deep past, archaeology goes silent. Modern humans have existed for at least 300,000 years, yet our earliest surviving art is only 45,000 years old. What happened during the other 255,000 years? Were our ancestors incapable of symbolic thought, or did earlier evidence simply not survive? Homo sapiens is at least 300,000 years old. The oldest known fossils, found in Morocco, date to around 315,000 years ago. Anatomically, these were modern humans, brains the same size as ours, bodies identical. Yet for more than 250,000 years, the archaeological record shows only the simplest stone tools, basic shelters, and survival activities. It's not until around 45,000 to 40,000 years ago that we see an explosion of symbolic behavior, cave paintings, carved figurines, complex tools, shell beads, musical instruments. What happened during those missing 250,000 years? The question has divided archaeologists for decades. On one side are those who argue for a cognitive revolution, a relatively sudden change in human mental capabilities that enabled modern behavior. On the other side are researchers who contend that humans were always cognitively modern, but that earlier evidence simply hasn't survived or hasn't been found. The debate cuts to the heart of what makes us human and when we became fully ourselves. The cognitive revolution hypothesis, championed by researchers like Richard Klein, proposes that around 50,000 years ago, a genetic mutation enhanced human brain function, particularly areas related to language and abstract thought. This neurological change, the theory goes, unlocked capabilities that had been dormant. Suddenly, humans could think symbolically, plan complex actions, create art, and develop sophisticated social structures. the explosion of material culture in the Upper Paleolithic, the period from roughly 45,000 to 12,000 years ago, reflects this cognitive leap. Supporting this view is the striking contrast between before and after. Before 50,000 years ago, the African and Eurasian archaeological records show mostly utilitarian stone tools with little regional variation. After 50,000 years ago, we see regional diversity, rapid innovation, personal ornaments, burial practices with grave goods, cave art, carved figurines, and bone tools with specialized functions. The difference is dramatic, suggesting something fundamental changed. The opposing view, articulated by scholars like Sally McBrearty and Alison Brooks, argues that behavioral modernity emerged gradually in Africa over hundreds of thousands of years. They point to evidence that predates the supposed revolution: shell beads from Blombos Cave in South Africa, dating to roughly 75,000 years ago, engraved ochre pieces from the same site showing deliberate geometric patterns, sophisticated stone tool technologies from the Middle Stone Age, and evidence of long-distance trade networks. These African finds suggest that symbolic thinking and complex behavior existed well before the Upper Paleolithic explosion in Europe. If that's true, then what looks like a sudden revolution might actually be the result of populations expanding out of Africa and leaving more visible traces, or simply a preservation bias, where earlier evidence is harder to find. The engraved ochre from Blombos is particularly significant. Dated to around 75,000 years ago, it shows a crosshatch pattern deliberately incised into a small piece of red ochre. The pattern is geometric, repetitive, and clearly intentional. Whether it's art, symbolic notation, or simple doodling is debated, but it demonstrates that someone 75,000 years ago was creating abstract marks, behavior we associate with symbolic thought. Shell beads from multiple African sites push evidence of personal ornamentation back to 100,000 years ago or more. These aren't random shells. They're deliberately chosen, perforated, and strung together. They represent adornment, identity marking, possibly trade or gift exchange. All of these activities require abstract thinking and social complexity. Burial practices provide another line of evidence. The earliest intentional burials appear around 100,000 years ago in the Middle East, with bodies placed in graves accompanied by objects. This suggests concern for the dead, belief in an afterlife, or at least social practices that treated deceased individuals as more than just bodies to be disposed of. These are not behaviors we'd expect from cognitively primitive beings, yet the puzzle remains. If humans were cognitively modern from the beginning, why is material evidence so sparse for most of our history? One answer is preservation. Most human activity leaves no permanent trace. Wooden tools rot, hide clothing decays, fiber baskets, woven mats, body paint made from ochre and plant dyes all disappear within years or decades. What survives is stone and, under exceptional conditions, bone and shell. We're looking at the most durable 1% of human material culture and drawing conclusions about behavior from that biased sample. Consider modern hunter-gatherer societies. Groups like the Hadza of Tanzania or the San of Southern Africa possess sophisticated knowledge systems, rich oral traditions, complex social structures, and diverse material cultures. Yet much of what they create is ephemeral. Their shelters are temporary. Their tools are often wooden. Their art includes body painting, sand drawings, and storytelling, none of which would survive even a few years after abandonment. If archaeologists found a Hadza camp 10,000 years from now, they'd recover stone tools and little else. Would they conclude the Hadza lacked symbolic thought? The same logic applies to Paleolithic humans. They may have been creating art on bark, wood, or hides. They may have worn elaborate fiber clothing decorated with dyes. They may have carved wooden sculptures that rotted away. They may have painted their bodies for ceremonies. None of this would leave archaeological traces unless preservation conditions were exceptional. Language poses another challenge. Modern humans almost certainly had fully developed language from early on. The FOXP2 gene associated with language shows signatures of selection around 300,000 years ago. If they could speak complex languages, they could tell stories, teach abstract concepts, and transmit cultural knowledge orally. None of that leaves fossils. The neurological evidence leans toward continuity. Human brain size reached modern levels more than 200,000 years ago. The structure of the vocal tract changed to enable the full range of speech sounds. The neural architecture for language processing was in place. From a biological standpoint, there's no clear reason why humans 150,000 years ago would have been cognitively different from us. Yet the archaeological silence is real. Between 300,000 and 50,000 years ago, material culture changes slowly. Innovation is rare. Regional variation is minimal. Then, starting around 50,000 years ago, everything accelerates. New tool types appear. Art emerges. Long-distance trade expands. Diversity explodes. Something changed, even if it wasn't cognition itself. One possibility is demographic. Larger, more connected populations innovate faster. As human populations grew and groups began interacting more frequently, ideas could spread and build on each other. Social networks expanded. Competition and cooperation drove innovation. The Upper Paleolithic explosion might reflect population dynamics rather than cognitive change. More people, more ideas, more pressure to innovate. Climate might also have played a role. The period around 50,000 years ago saw significant environmental changes. New opportunities and challenges could have driven cultural innovation. Groups adapting to diverse environments would have developed specialized tools and techniques, creating the regional variation we see in the archaeological record. Migration patterns matter too. As humans spread out of Africa into Europe, Asia, and eventually Australia and the Americas, they encountered new environments requiring new solutions. This adaptive radiation would naturally produce diverse material cultures. The archaeological record becomes richer because humans were doing more varied things in more places. There's also the possibility that symbolic behavior was always present, but expressed in ways that didn't create durable artifacts. If Paleolithic humans sang, danced, told stories, and painted their bodies, they were engaging in symbolic activity that would leave almost no trace. The difference in the Upper Paleolithic might be that they started creating symbolic expressions in more durable media, carving bone instead of wood, painting cave walls instead of bark shelters. The debate is unlikely to be resolved definitively. We can't excavate cognition directly. We can only infer mental capabilities from the objects people made and the actions they took. And when most objects decay and most actions leave no trace, inference becomes guesswork. All we can say with confidence is that the archaeological record for early Homo sapiens is fragmentary and biased. We see stone tools because stone survives. We don't see wooden tools, fiber crafts, or ephemeral art because they decay. The apparent simplicity of early human material culture might reflect what preserves rather than what existed. So for 250,000 years, did humans lack the cognitive capacity for complex culture? Or were they creating art, telling stories, and building knowledge systems that simply left no trace? The difference matters. If earlier humans were cognitively modern, but their achievements didn't survive, then the archaeological silence of deep time may hide entire civilizations, not in the sense of cities and writing, but in the sense of complex cultures, rich oral traditions, and sophisticated knowledge of the natural world. Wood rots, paint fades, songs are forgotten, and 100,000 years is a very, very long time. The silence of early prehistory raises uncomfortable questions about what humans were capable of and when. But even in more recent times, the past 15,000 years, evidence suggests some cultures possessed astronomical knowledge far beyond what we'd expect. On the winter solstice, the shortest day of the year, sunlight penetrates the passage tomb at Newgrange in Ireland, a structure built around 30 to 200 BCE, 500 years before the Great Pyramid. For 17 minutes, a shaft of light illuminates the inner chamber, a feat requiring precise calculation of the sun's annual path. Halfway across the world, at Chaco Canyon in New Mexico, ancestral Puebloans carved a spiral petroglyph that marks the summer solstice when light passes through it, just so. At Stonehenge, the heel stone aligns with the sunrise on midsummer. These are not accidents. They represent astronomical knowledge developed through centuries of patient observation by people we often dismiss as primitive. Newgrange is older than writing, older than the wheel in most of the world, older than bronze working in Western Europe. Yet its builders understood the sun's movement well enough to construct a monument that captures a specific moment once a year. The passage tomb is oriented precisely to the winter solstice sunrise. On December 21st, when the sun reaches its lowest point in the sky, its rays enter through a specially designed roof box above the entrance and travel 19 meters down the passage to light up the burial chamber. The alignment is accurate to within degrees, maintained for more than 5,000 years, despite the precession of Earth's axis. Stonehenge, built in stages between roughly 3000 and 2000 BCE, shows even more sophisticated astronomical awareness. The heel stone marks the midsummer sunrise when viewed from the center of the circle. The station stones form a rectangle whose sides align with significant lunar positions. Some researchers argue that Stonehenge functioned as a calculator for predicting eclipses, though this interpretation remains controversial. What's undeniable is that the monument's builders understood solar and possibly lunar cycles well enough to encode them in massive stone architecture. At Carnac in Brittany, France, thousands of standing stones stretch across the landscape in aligned rows. The site dates to around 4500 BCE, making it older than Stonehenge and roughly contemporary with the earliest phases of construction at nearby megalithic tombs. While the precise astronomical function of Karnak is debated, some alignments correspond to significant solar and lunar positions. Whether this was intentional or coincidental is unclear, but the scale of the construction suggests organized effort and possibly sophisticated understanding of celestial patterns. Chaco Canyon, in the present-day New Mexico, contains multiple astronomical markers. The Sun Dagger site, discovered in 1977, consists of a spiral petroglyph positioned behind 3 stone slabs. On the summer solstice, a dagger of light passes through the center of the spiral. On the winter solstice, 2 daggers bracket the spiral. At the equinoxes, smaller daggers mark the edges. The precision suggests generations of observation to perfect the alignment. Other sites in Chaco show similar attention to solar and lunar positions, indicating that astronomy was central to ancestral Puebloan culture between approximately 900 and 1150 CE. The Egyptian pyramids at Giza are aligned to cardinal directions with remarkable precision. The Great Pyramid sides face north, south, east, and west to within fractions of a degree. How the builders achieved this accuracy remains debated. Some propose they used the stars, perhaps noting where a circumpolar star rose and set and bisecting the angle. Others suggest shadow measurements or plumb bobs. Whatever the method, the result demonstrates sophisticated surveying and astronomical observation around 2600 BCE. The so-called Orion correlation theory, which claims the 3 main pyramids at Giza map the belt stars of Orion, remains controversial. While the general layout is suggestive, the precision of the match is disputed, and many Egyptologists see the correlation as coincidental or overstated. Still, Egyptian texts make clear that the pharaohs associated themselves with Orion and other celestial features, so astronomical symbolism in pyramid placement wouldn't be surprising. Mayan astronomy represents perhaps the most sophisticated pre-modern astronomical system in the Americas. The Maya developed a complex calendar system that tracked multiple cycles simultaneously: a 260-day ritual calendar, a 365-day solar year, a 584-day Venus cycle, and a long count that measured time from a mythological creation date. They could predict eclipses, track planetary movements, and calculate dates thousands of years in the future or past. This required centuries of careful observation and mathematical sophistication. The Dresden Codex, one of only 4 surviving Mayan books, contains detailed astronomical tables, including predictions for Venus appearances and lunar eclipses. The accuracy of these predictions suggests the Maya understood celestial mechanics well enough to model planetary motion, even without telescopes or modern mathematics. Their knowledge was encoded in stone inscriptions, painted in codices, and passed down through priestly lineages. Nabta Playa in southern Egypt offers evidence of even earlier astronomical sophistication. Stone circles at the site, dated to roughly 7,000 to 6,500 years ago, may align with the summer solstice and certain stars. If these alignments are intentional, and not all researchers agree they are, they would represent the world's oldest known astronomical monument, predating Stonehenge by over 3,000 years. The people who built Nabta Playa were pre-dynastic pastoralists, following cattle herds and living in seasonal camps. Yet they may have constructed stone circles to mark celestial events. The pattern is global. In Peru, the 13 towers of Chanquillo, built around 300 BCE, mark the rising and setting positions of the sun throughout the year, functioning as a solar calendar. In Cambodia, Angkor Wat's layout incorporates astronomical alignments with the spring equinox and various stellar positions. In China, ancient texts describe sophisticated astronomical observations dating back at least 3,000 years, used for calendar making and divination. What all these examples share is the investment of effort. Aligning a structure to a solstice sunrise isn't trivial. It requires observing the sun's position over many years to determine its exact northernmost rising point. It requires surveying skills to orient a building precisely, and it requires mathematical understanding to calculate angles and positions. These weren't accidental achievements. They were the result of systematic observation passed down across generations. Why did ancient cultures care so much about astronomy? Practical reasons certainly mattered. Agricultural societies needed calendars to know when to plant and harvest. Tracking seasons required observing celestial patterns. The sun, moon, and stars provided the most reliable timekeeping available. But the effort invested in monuments suggests astronomy also had religious and symbolic significance. The heavens represented the realm of gods. Celestial events carried meaning. Aligning earthly structures with celestial patterns connected human society to cosmic order. There are fascinating tidbits in the details. At Stonehenge, the Sarsen stones, the massive ones forming the outer circle and inner horseshoe, were quarried from Marlborough Downs, about 25 kilometers away. Each stone weighs up to 30 tons. The smaller bluestones came from Wales, over 200 kilometers distant. Transporting these stones required extraordinary effort, suggesting the site's astronomical function was profoundly important to its builders. At Newgrange, the roof box that admits winter solstice light wasn't discovered until modern excavations. For centuries, the passage was blocked, and the alignment was unknown. When archaeologist Michael O'Kelly observed the phenomenon in 1967, he was witnessing something that hadn't been seen for thousands of years, proof that ancient builders had encoded knowledge that outlasted their culture. The Mayan long count calendar's starting date of August 11th, 3114 BCE in the Gregorian calendar is mythological, not historical. Yet the Maya could calculate dates millions of years in the past or future using this system. One inscription at the site of Koba projects forward to a date 41 octillion years in the future, far beyond the predicted lifespan of the universe. This wasn't practical astronomy. It was mathematical play, demonstrating that ancient astronomers could think abstractly and speculatively. Polynesian navigators used the stars to cross thousands of miles of open ocean. They memorized the rising and setting positions of dozens of stars, using them as compass points. They could read wave patterns, cloud formations, and bird behavior to determine direction and proximity to land. This knowledge was transmitted orally, requiring prodigious memory and years of training. It represents a different kind of astronomy, not monuments or calendars, but a practical navigation system that enabled one of history's greatest maritime expansions. Skeptics caution against over-interpreting ancient astronomical knowledge. Just because a structure aligns with a celestial event doesn't mean it was designed for that purpose. With enough structures and enough celestial events, some alignments will occur by chance. The challenge is distinguishing intentional from coincidental alignments. Critics argue that modern researchers sometimes cherry-pick alignments while ignoring misalignments, creating an impression of greater astronomical sophistication than actually existed. This skepticism is healthy. Not every stone circle is an observatory. Not every alignment is meaningful. But when structures show multiple precise alignments, when cultural evidence suggests astronomical interests, and when the alignments required observable effort to achieve, dismissing them as coincidence becomes harder to justify. Ancient astronomical knowledge reveals something important. Sophisticated understanding doesn't require writing. For thousands of years, cultures around the world tracked the heavens, predicted eclipses, and marked celestial cycles without ever recording their methods in texts we can read. The knowledge was encoded in stones, passed through oral tradition, and demonstrated through ritual. But oral knowledge is vulnerable. When a culture collapses, when the elders die, when the traditions fade, even the most sophisticated astronomical understanding can vanish as if it never existed. The monuments remain. The knowledge behind them is often gone. Astronomical knowledge was preserved in stones. But some knowledge was never meant to be preserved at all. Oral traditions carried only in memory, including stories that may describe encounters with species we didn't know existed until modern genetics revealed them. In 2016, geneticists analyzing DNA from modern West Africans discovered something unexpected. Traces of an unknown human species. Not Neanderthal, not Denisovan. Something else entirely. An archaic human population that interbred with the ancestors of modern West Africans, leaving fragments of its genome behind, but no fossils, no tools, no clear archaeological trace. Researchers call these ghost populations. They're visible only in our genes, their existence inferred from statistical analysis of DNA, and they raise an unsettling possibility. How many human species existed alongside us that we've never found? The discovery came from studying patterns of genetic variation in modern human populations. When researchers sequence genomes from people across Africa, Asia, and other regions, they can identify segments of DNA that don't match the typical patterns of modern human evolution. Some of these anomalous segments are explained by Neanderthal or Denisovan admixture. We know those species interbred with Homo sapiens, but other segments don't match any known archaic human. They're too divergent, suggesting they came from populations that separated from our lineage hundreds of thousands of years ago. The West African ghost population is one example. In 2020, a study led by geneticist Sriram Sankararaman identified archaic DNA in the genomes of people from Nigeria and Sierra Leone. The DNA doesn't match Neanderthals or Denisovans. Statistical modeling suggests it came from a population that split from other humans perhaps 500,000 years ago and interbred with the ancestors of modern West Africans within the past 50,000 years. The introgression accounts for roughly 2 to 19% of ancestry in some individuals, comparable to Neanderthal contributions in Eurasians. But there are no fossils, no skulls, no teeth, no bones that we can definitively link to this ghost population. They exist only in the genetic record, inferred from patterns of variation that require explanation. It's as if we discovered a species through its shadow rather than its substance. A similar case emerged in 2021 when researchers analyzing Denisovan DNA found evidence of interbreeding with yet another unknown population. The Denisovans themselves interbred with at least 2 distinct groups of archaic humans in Asia, one related to Neanderthals, another representing a deeply divergent lineage. Some geneticists now propose that there may have been multiple waves of archaic human admixture, each leaving faint traces in modern genomes. In the Philippines, genetic analysis of indigenous Aita populations revealed high levels of Denisovan ancestry, higher than in any other modern population. But the Denisovan DNA itself shows structure suggesting at least 2 distinct Denisovan populations contributed genes at different times. One introgression event occurred roughly 50,000 years ago. Another may have been more recent. Each represents a separate encounter between modern humans and archaic populations. The methodology behind these discoveries is complex but elegant. Geneticists compare modern human genomes to Neanderthal and Denisovan genomes reconstructed from ancient DNA. Any segments that don't match either the modern human baseline or known archaic humans must come from somewhere. Statistical models can estimate when these mystery segments entered the modern human gene pool, how long ago the source population diverged from other humans, and roughly how much genetic material was exchanged. The challenge is that without physical remains, we can't know what these ghost populations looked like, where exactly they lived, or how they behaved. We can infer their existence and estimate their divergence times, but we can't see them, name them properly, or place them in the human evolutionary tree with confidence. They're genetic phantoms. This has profound implications for understanding human diversity. The traditional picture showed a relatively simple tree, Homo erectus giving rise to various regional populations, which eventually were replaced or absorbed by modern humans spreading out of Africa. Neanderthals and Denisovans complicated that picture, but they were still just two additional branches. Now we're discovering that the human family tree during the Pleistocene was far bushier than anyone imagined. Multiple human species and populations coexisted, overlapped geographically, and occasionally interbred. Some of these populations are completely unknown to us, except through genetics. Others we may have fossils for, but can't connect to the genetic data. Homo naledi in South Africa, Homo luzonensis in the Philippines, and the Homo floresiensis in Indonesia all represent recently discovered human species with unusual characteristics. Could any of them be the sources of ghost DNA? Without ancient DNA from their fossils, difficult or impossible to recover in tropical climates, we can't say for certain. The fossil record for human species is notoriously sparse. Finding hominin fossils requires exceptional preservation conditions and usually some luck. Most individuals who died in prehistory left no trace. Their bodies decomposed, were scavenged, or were destroyed by geological processes. The fossils we do find represent an infinitesimally small sample of past populations. If ghost populations existed in small numbers or in regions where fossilization was unlikely, they could have lived and died without leaving any bones for us to find. DNA, however, is more generous. Even a brief period of interbreeding can leave genetic traces that persist for tens of thousands of years. If a few individuals from a ghost population interbred with modern humans, and their offspring had descendants who survived, fragments of ghost DNA would propagate through the generations. Today, those fragments are scattered across millions or billions of people, detectable through sequencing and statistical analysis even when no physical remains exist. This creates a strange asymmetry. We have more evidence for some human species' existence in our genomes than in the ground. Genetics reveals populations that archaeology cannot. But genetics also has limits. It can tell us that interbreeding occurred, but not the context. Was it friendly contact between neighboring groups? Rare encounters at the edges of territorial ranges? Violence and coercion? The DNA itself doesn't preserve these details. The percentage of archaic DNA in modern humans varies by population and ancestry. Europeans and Asians typically carry about 2% Neanderthal DNA. Melanesians and Aboriginal Australians carry up to 6% Denisovan DNA. West Africans carry ghost population DNA in varying amounts. But these percentages represent only what survived. Many more archaic gene variants likely entered the modern human gene pool and were later lost through genetic drift or natural selection. What we detect today is the minimum contribution, not the total. Some of these archaic genes provided adaptive advantages. Denisovan DNA includes variants that help with high-altitude adaptation, still present in Tibetan populations. Neanderthal genes contribute to immune function and skin pigmentation. Ghost population DNA may carry similar benefits, helping modern humans adapt to the specific challenges of West African environments. Natural selection preserved these useful variants, while eliminating neutral or harmful ones, shaping the pattern of archaic ancestry we see today. The discovery of ghost populations also changes how we think about human uniqueness. For most of our history, we shared the planet with other human species. We weren't alone, just the ones who survived. Those other humans were different from us, genetically, probably behaviorally, but not so different that interbreeding was impossible. The boundaries between species were permeable, at least occasionally. That suggests a more complex and perhaps more interesting human story than the narrative of a single species spreading across the world. Each new genetic study seems to reveal more complexity. In 2019, analysis of DNA from a bone fragment in Denisova Cave revealed a girl whose mother was Neanderthal and father was Denisovan, a first-generation hybrid. If Neanderthals and Denisovans could interbreed, and both could interbreed with modern humans, then encounters between human populations must have been more common than we thought. And if we're finding ghost populations in genetic data, how many more might exist that we haven't detected yet? The technical challenges shouldn't be understated. Detecting ghost populations requires large sample sizes, high-quality genomic data, and sophisticated statistical models. Early genetic studies lacked the resolution to identify these subtle signals. As sequencing technology improves and more populations are sampled, we'll likely discover additional ghost populations. Each one will expand our understanding of human diversity while highlighting how much we don't know. But the question of lost knowledge and civilizations, ghost populations offer a sobering lesson. Entire human species can exist, thrive for hundreds of thousands of years, interbreed with our ancestors, and then vanish from the archaeological record so completely that only genetics reveals they were ever here. If species can disappear this thoroughly, how much harder would it be to find evidence of specific cultures or knowledge systems within those species? Ghost populations prove that the absence of fossils doesn't mean absence of existence. Entire human species lived, thrived, and interbred with our ancestors, yet they left no bones, no tools, no caves with their remains. Only the faintest echoes in our DNA reveal they were ever here. If species that existed as recently as 50,000 years ago can be this invisible, how many others lived and vanished before even that, leaving no trace at all? Not in fossils, not in genes, not in memory. Genetics reveals ghost populations, but the archaeological record has its own silences. Vast gaps where cultures should exist, but don't. In the transition from simple hunter-gatherers to complex civilizations, entire evolutionary steps seem to be missing. Evolution is supposed to be gradual. Populations slowly develop new technologies, Villages grow into towns, towns into cities. Yet when archaeologists look at the record, they often find not gradual change, but sudden appearance. Agriculture seems to emerge almost simultaneously in multiple regions around 10,000 BCE. Cities like Uruk and Çatalhöyük appear fully formed with little evidence of experimental predecessors. Writing systems arise with sophisticated grammar and vocabulary already in place. Where are the transitional cultures, the half-developed cities, the proto-writing systems, the trial runs of agriculture? The Neolithic Revolution is perhaps the clearest example. For hundreds of thousands of years, humans lived as hunter-gatherers, following herds and gathering wild plants. Then, within a few thousand years, a blink in evolutionary time, multiple societies independently developed agriculture. In the Fertile Crescent around 10,000 BCE, people began cultivating wheat and barley. In China around 9,000 BCE, rice and millet were domesticated. In Mesoamerica around 8,000 BCE, squash and later maize came under cultivation. In the Andes, potatoes and quinoa were domesticated by 6,000 BCE. The conventional explanation is that these developments occurred independently, but under similar pressures. Climate change at the end of the Ice Age made some regions more suitable for plant cultivation. Population growth in certain areas pushed groups to intensify their food production. Wild cereal stands became reliable enough to support semi-sedentary populations, creating conditions where experimentation with cultivation could occur. Once the benefits of agriculture became clear, the practice spread and intensified rapidly. But the transitions look abrupt in the archaeological record. We find wild plant remains, then domesticated plant remains, with relatively little evidence of the intermediate stages where people were managing wild stands or conducting early experiments. The physical changes that mark domestication, larger seeds, tougher stems, loss of natural seed dispersal, appear relatively quickly in the archaeological layers. Either domestication happened faster than we'd expect from gradual selection, or the intermediate stages are missing from the record. Jericho in the Jordan Valley offers another puzzle. By 9000 BCE, the site shows evidence of a settlement with stone walls and a tower, suggesting organized defense and labor coordination. This is before widespread agriculture in the region. The people of early Jericho were still primarily hunter-gatherers, yet they built permanent structures and lived in a dense community. Where are the transitional settlements, showing the gradual shift from mobile camps to permanent villages? They exist, but they are rare and poorly understood. Çatalhöyük in modern Turkey presents a similar challenge. Around 7500 BCE, it was already a large, densely packed settlement with sophisticated architecture. Houses built wall-to-wall, accessed through roof openings, decorated with murals and sculptures. The site appears in the archaeological record as a mature settlement. Earlier phases exist, but they show the same general pattern, rather than a clear progression from simpler forms. It's as if the inhabitants knew from the beginning how to create urban density. Uruk in Mesopotamia, often considered the world's first true city, emerges around 4000 BCE with monumental architecture, administrative buildings, and specialized craft production already in place. Earlier villages existed in the region, but the jump from village to city seems rapid. By 3200 BCE, Uruk had a population of perhaps 40,000 people, massive temples, a complex economy, and the earliest writing. Where are the intermediate settlements, showing the gradual development of urban planning, centralized authority, and bureaucratic organization. Writing presents the same pattern. When cuneiform appears in Mesopotamia around 3200 BCE, it's not crude scratches, but a system capable of recording language with reasonable precision. The earliest tablets from Uruk show a counting notation, but within centuries, the system was being used for literature, law, and correspondence. Egyptian hieroglyphs appear around 3200 BCE as well, already sophisticated enough to record royal names and religious texts. Where are the centuries of experimentation we'd expect as people figured out how to encode language in visual symbols? The counter-argument is that transitional stages are hard to recognize. Early writing might have been on perishable materials, wood, bark, leather, that didn't survive. Proto-cities might have been built primarily from mud brick or wood, materials that decay rapidly in most climates. The remains we find are the successful end results, the versions that worked well enough to be replicated and refined, the failed experiments, the dead ends, the gradual improvements. All might have used materials or occurred in places where preservation was poor. There's also the problem of archaeological visibility. We find what we look for and what survives. Stone tools survive, so we have stone tool sequences showing gradual change. But fiber crafts, wooden implements, hide working, and other perishable technologies could have been developing alongside stone tools, showing equal or greater complexity. If early pottery was unfired, or if early baskets were made from materials that rotted, we'd have no evidence they existed. Göbekli Tepe, which we examined earlier, stands as the most dramatic example of this pattern. Temples appear before villages, monumental architecture before agriculture, complex organization before settled life. The conventional sequence: settled villages, then surplus food, then specialized labor, then monuments, is reversed. Either our model of social development is wrong, or Göbekli Tepe represents something unique that doesn't fit the normal pattern. Some archaeologists argue that the transitions were genuinely rapid, that once key insights were achieved, they spread quickly through contact and cultural transmission. Agriculture, once demonstrated to be viable, could be adopted within a generation or two. City planning, once someone figured out how to manage large populations in dense settings, could be replicated elsewhere. Writing, once the principle of encoding language in symbols was understood, could be developed independently by different cultures using different symbol systems. Others point to preservation bias. The sites we find tend to be substantial, made of durable materials, or located in areas where excavation has occurred. Small experimental settlements, transitional technologies, and failed attempts might exist but remain undiscovered. Every year brings new finds that fill in gaps. Early pottery in China keeps getting pushed back as new sites are found. Pre-Uruk settlements in Mesopotamia show more complexity than previously recognized. The picture is constantly being refined. But certain gaps persist. The transition from Paleolithic to Neolithic, from foraging to farming, from mobile to settled, shows surprisingly little evidence of the messy middle phases. We see hunter-gatherers, then we see farmers. The gradual shift, the experimentation, the back and forth between strategies, all are underrepresented in the archaeological record compared to what we'd expect from evolutionary theory. Consider that many innovations require multiple supporting technologies. To have writing, you need not just symbols, but also a reason to record information, materials to write on, a trained class of scribes, and social complexity that generates information worth recording. To have cities, you need surplus food production, social organization to prevent conflict in dense populations, sanitation systems, specialized labor, and trade networks. These are package deals. The archaeological record shows us the complete packages, but not always the intermediate steps where components were being developed and tested. There are hints of complexity in unexpected places. Stone tools from 300,000 years ago show regional variations and sophisticated production techniques. Ochre use extends back 100,000 years, more, suggesting symbolic thinking long before the Upper Paleolithic. Shell beads appear tens of thousands of years before the supposed explosion of symbolic behavior. These hints suggest that complexity was developing earlier and more gradually than the major archaeological transitions suggest. But they're just hints, fragments that don't form a complete narrative. Modern excavation methods are revealing more than older techniques did. Flotation to recover plant remains, microscopic analysis of stone tools to detect use wear, residue analysis on pottery to identify contents. All these methods extract information that earlier archaeologists missed. As we go back and re-examine old sites or excavate new ones with better methods, we're filling in some gaps. But many sites have been destroyed by development, erosion, or earlier excavations that didn't preserve all the information. The question remains whether the gaps are real, representing genuinely rapid cultural changes, or artifacts of an incomplete record. If development was truly gradual, then the archaeological record is even more fragmentary than we acknowledge, and we're missing most of the story. If development was rapid, then human cultural evolution doesn't follow the smooth, gradualist pattern we expect from biological evolution. Either way, we're working with incomplete data. The missing transitional cultures leave us with a dilemma. Either human development was far more rapid than evolutionary theory would predict, sudden leaps rather than gradual change, or the archaeological record is systematically incomplete, hiding the very evidence that would show us how civilizations actually emerged. Both possibilities are unsettling. Rapid leaps require explanation. And if the record is that incomplete, then entire chapters of human cultural evolution might be missing, lost to time and decay. Gaps in the archaeological record raise questions about what's missing. But some theorists go further, proposing that catastrophes don't just create gaps, they repeat in cycles, destroying civilizations over and over throughout deep time. What if human history isn't linear but cyclical? What if civilizations rise, develop, achieve heights of knowledge and sophistication, and then are wiped out by catastrophes, forcing survivors to start over from scratch? This is the theory of cyclic catastrophism, that Earth experiences periodic disasters violent enough to erase nearly all traces of what came before. To mainstream academics, this is pseudoscience, the domain of Atlantis hunters and doomsday prophets. But some geological evidence, impact craters, magnetic field reversals, climate shifts, suggests that catastrophes do recur, even if their effects are less dramatic than catastrophists claim. The cyclic catastrophism hypothesis takes several forms, depending on which mechanism is proposed. Some advocates focus on cosmic impacts, asteroids or comets striking Earth at regular intervals, perhaps related to the solar system's movement through the galactic plane or encounters with debris fields. Others emphasize magnetic pole reversals, arguing that when Earth's magnetic field flips, the transition period leaves the planet vulnerable to solar radiation and cosmic rays. Still others point to solar events like superflares or the more speculative micronova theory, which proposes that the Sun undergoes periodic outbursts powerful enough to devastate Earth's surface. Climate cycles offer a more mainstream version of catastrophism. Milankovitch cycles, variations in Earth's orbit and axial tilt, drive ice ages on timescales of tens of thousands of years. These cycles are real, well documented, and have profound effects on habitability. During glacial maxima, much of the northern hemisphere becomes uninhabitable. During interglacials like our current period, ice retreats and populations expand. The transition between these states has been rapid at times, potentially disrupting human societies. Volcanic super-eruptions provide another mechanism. Toba, which we've already discussed, erupted 74,000 years ago, with effects that may have reduced human populations to the brink of extinction. Yellowstone in North America has erupted catastrophically at roughly 600,000-year intervals, with the last major eruption occurring 640,000 years ago. The Taupo supervolcano in New Zealand erupted 26,500 years ago, ejecting enough material to darken skies across the southern hemisphere. These events are rare but devastating, capable of causing global climate disruption and mass die-offs, and the geological record confirms that catastrophes happen. The Cretaceous Paleogene extinction 66 million years ago was caused by an asteroid impact that wiped out the dinosaurs. The Permian Triassic extinction 252 million years ago, possibly triggered by massive volcanic eruptions, killed 96% of marine species. More recently, the Younger Dryas climate reversal, whether caused by impacts, volcanic activity, or ocean circulation changes, demonstrates that rapid environmental shifts can occur within human timescales. Impact craters dot Earth's surface, though erosion and plate tectonics have erased many. The Barringer crater in Arizona, formed about 50,000 years ago, is well preserved and serves as a reminder that impacts continue. The Tunguska event in 1908, when an airburst explosion over Siberia flattened 2,000 square kilometers of forest, shows that even relatively small cosmic objects can cause local devastation. Larger impacts would have global consequences. Magnetic pole reversals are also real. Earth's magnetic field has flipped many times, with the last reversal occurring roughly 780,000 years ago. During a reversal, the field weakens substantially, potentially allowing more cosmic radiation to reach the surface. The transition can take thousands of years, and while life has survived every previous reversal, the effects on complex technological civilizations could be severe. Increased radiation, disruption of navigation systems, and damage to electrical infrastructure would challenge any society dependent on technology. But here's where the theory runs into problems. While catastrophes are real, the pattern of regular, predictable cycles destroying advanced civilizations lacks evidence. Milankovitch cycles operate on timescales of tens of thousands of years, not the thousands or hundreds that would be relevant to erasing historical civilizations. Magnetic reversals occur irregularly, not on a fixed schedule. Volcanic super-eruptions are random, clustered in volcanically active regions rather than distributed globally on a timeline. And while impacts happen, their frequency decreases with size, civilization-ending impacts are exceedingly rare. Academic critics point out that proponents of cyclic catastrophism often cherry-pick data. They focus on real catastrophes, Toba, the Younger Dryas, historical earthquakes and floods, while ignoring the lack of pattern. Yes, Toba erupted 74,000 years ago, but there's no comparable eruption 74,000 years before that, or 74,000 years after. Yes, the Younger Dryas was abrupt, but it wasn't part of a 12,000-year cycle that repeats with regularity. Catastrophes are scattered across deep time without the rhythmic recurrence that would support a cyclic theory. Moreover, the archaeological record shows cultural continuity far more often than sudden erasure. The transition from Paleolithic to Neolithic, from foraging to farming, from villages to cities, all show gradual development with regional variations. There's no evidence of a global reset where all human societies collapsed simultaneously and restarted from zero. Regional collapses occur: the Bronze Age collapse, the fall of Rome, the abandonment of Angkor. But these are staggered in time and space, not synchronized global events. Proponents like Graham Hancock have argued that myths of lost civilizations like Atlantis preserve memories of societies destroyed by catastrophes, particularly at the end of the last ice age. The theory is that rising sea levels and climate disruption around 12,000 years ago drowned advanced coastal civilizations, erasing them so completely that only myths remain. But as we've discussed, archaeological evidence from submerged continental shelves shows human habitation consistent with Mesolithic hunter-gatherer cultures, not advanced urban civilizations. Randall Carlson and others have focused on the Younger Dryas impact hypothesis, arguing that cosmic impacts not only triggered climate change, but also destroyed an advanced civilization whose knowledge was passed down through myths and megalithic monuments. The idea is appealing. It ties together geological events, archaeological mysteries, and mythological narratives into a single explanatory framework. But it requires assuming that a civilization advanced enough to leave no recognizable trace except in mythology existed and was completely erased, a claim that strains credulity without supporting evidence. The solar micronova theory, popular in some alternative circles, proposes that the Sun undergoes periodic outbursts that scour Earth's surface, causing pole shifts and mass extinctions. The theory draws on observations of other stars that exhibit flaring behavior and on disputed interpretations of geological layers as evidence of past solar events. Mainstream astrophysics rejects the micronova hypothesis. The Sun is a stable main sequence star. Its variability follows an 11-year cycle of sunspot activity, not catastrophic outbursts, and there's no geological evidence for the kind of surface sterilization that a micronova would cause. Real solar cycles do exist. The 11-year sunspot cycle affects space weather, causing auroras and occasionally disrupting satellites and power grids. Longer cycles, like the Maunder Minimum, 1645, 1715, a period of reduced solar activity that coincided with colder temperatures in Europe, show that solar variations can influence climate. But these are minor perturbations, not civilization-ending events. There are tidbits that keep catastrophism alive in popular imagination. The Clovis culture's disappearance at the Younger Dryas boundary, megafauna extinctions across multiple continents, flood myths from around the world, all suggest that something significant happened around 12,000 years ago. But significant doesn't mean civilization-destroying cycle. It means climate change, sea levels rose, and ecosystems shifted, disrupting human populations in ways that left memories but not evidence of advanced societies. The question of what it would take to erase an advanced civilization completely is worth considering. A global catastrophe, multiple simultaneous impacts, a supervolcano orders of magnitude larger than anything in the historical record, or a geomagnetic reversal coinciding with massive solar flares, could potentially destroy industrial infrastructure and reduce populations drastically. But would it erase all traces? Unlikely. Our species has a 300,000-year history of recovering from disasters. Survivors would persist in some regions, carrying knowledge forward, and material traces, stone foundations, metal artifacts, chemical signatures in sediments would remain detectable for tens of thousands of years. The strongest argument against cyclic catastrophism is the absence of archaeological gaps that would indicate civilizational resets. If advanced societies rose and fell repeatedly, we'd expect to see layers in the geological record showing complex artifacts, followed by stark absences, followed by renewed complexity. We'd expect to find ruins overlaid by ruins, separated by sterile layers representing the catastrophic events. While regional collapses show this pattern on local scales, there's no global evidence of synchronized resets. Catastrophism has a grain of truth. Disasters do happen. Toba erupted. Asteroids have struck Earth. Climate has changed rapidly. But the idea that these events recur in predictable cycles, systematically erasing advanced civilizations, lacks evidence. The geological record shows catastrophes scattered across vast timescales, not regular pulses. And the archaeological record, despite its gaps, shows cultural continuity far more often than abrupt erasure. If advanced civilizations rose and fell repeatedly, we'd expect more evidence, not none. Still, the question lingers: how complete could erasure be? And if it were complete, how would we know? Catastrophe theories speculate about what could erase evidence, but to understand whether ancient advanced civilizations could truly disappear without trace, we need to ask a more fundamental question. What actually survives deep time? Imagine all evidence of modern civilization disappeared tomorrow. Humans vanish. Nature reclaims the cities. 10,000 years pass. What would survive? The obvious answer is stone monuments, the pyramids, Mount Rushmore, perhaps some foundations. But almost everything else would be gone. Steel rusts, concrete cracks and crumbles. Plastics break down into microparticles. Glass shatters. Wood rots. Paper disintegrates. Electronics corrode. Within millennia, nearly every trace of our technological civilization would be erased. Only geologists examining chemical signatures in sediment layers might detect that something unusual happened here. Understanding what materials survive deep time is crucial for evaluating whether ancient advanced civilizations could exist but remain undetected. If most evidence decays within thousands of years, then absence of artifacts doesn't necessarily mean absence of capability. The preservation bias in archaeology is severe, and it gets worse the further back we look. Stone is the most durable construction material available to pre-industrial societies. Granite, limestone, and other hard stones can survive millions of years with minimal degradation. Weathering occurs, surfaces erode, inscriptions fade, carved details soften, but the basic structure endures. This is why ancient stone monuments like Stonehenge, the pyramids, and megalithic sites persist while contemporary structures built from other materials have vanished. For anything to survive 10,000 years or more, Stone is almost essential. Ceramics come next in durability. Fired clay is essentially rock, resistant to biological decay and most chemical processes. Pottery sherds can survive tens of thousands of years if not subjected to extreme mechanical stress. Even when vessels break, the fragments persist, which is why pottery is so common in archaeological sites. Unfired clay, however, dissolves rapidly when exposed to water, limiting its preservation to very dry environments. Bronze and copper can last thousands of years, though they corrode. In dry conditions or when buried in certain soil types, bronze artifacts survive remarkably well. Copper develops a protective patina that slows further corrosion. But in humid environments or acidic soils, metals degrade more rapidly. After 5 to 10,000 years, most bronze objects would be heavily corroded or reduced to unrecognizable lumps of oxide. Iron and steel have much shorter lifespans. In moist conditions, iron rusts completely within centuries. Steel, despite being harder and more useful than bronze, is less durable archaeologically. A steel bridge or skyscraper frame exposed to weather would rust away in hundreds of years, leaving little but stains in the soil. Any Iron Age civilization that relied heavily on steel tools and structures would leave minimal metal artifacts after 10,000 years. Glass is durable but brittle. Roman glass survives in archaeological contexts, though it often becomes cloudy or develops an iridescent patina. Glass can persist for tens of thousands of years if conditions are right, but it shatters easily, breaking into fragments that are hard to recognize as artifacts rather than natural formations. Modern glass, being chemically similar to ancient glass, would face the same preservation challenges. Wood survives only under exceptional conditions. In normal circumstances, wood rots within decades to centuries, consumed by fungi, bacteria, and insects. But in waterlogged environments where oxygen is absent, in extremely dry deserts, or when charred by fire, wood can survive thousands of years. Wooden artifacts from Egyptian tombs, bog bodies in peat, and charred remains from prehistoric fires demonstrate that preservation is possible but rare. Most wooden structures and tools leave no trace. Organic materials, cloth, leather, rope, paper, parchment, decay even faster than wood. Only in the driest deserts or most oxygen-depleted bogs do these materials survive more than centuries. The textiles, books, and documents that civilizations produce are among the first things to vanish. A library full of books would leave no trace after a few thousand years, unless preserved in extraordinary conditions like the Dead Sea caves. Plastics present an interesting case. Modern plastics can persist for centuries, possibly millennia, but they don't remain intact. They break down into microplastics, particles too small to be recognized as manufactured objects. In 10,000 years, plastic artifacts would likely be reduced to chemical traces scattered through sediments, detectable analytically, but not visually identifiable as products of technology. Exceptional preservation occurs in specific environments. Permafrost freezes organic materials, preventing decay. Ötzi the Iceman, found in alpine ice, preserves soft tissue, clothing, and equipment for 5,300 years. Peat bogs are anaerobic, preventing bacterial decay. Bog bodies and wooden trackways survive because oxygen can't reach them. Extremely arid deserts, like Egypt's, desiccate organic materials before they can rot. And underwater sites in low oxygen conditions can preserve wood and other materials that would decay on land. But these exceptional conditions are rare and localized. Most human activity occurs in environments where preservation is poor. Temperate forests, grasslands, and tropical regions where much of human history has played out offer minimal preservation beyond stone and ceramics. After 10,000 years, even favorable environments lose most traces of human activity. Chemical signatures offer another avenue of detection. Heavy metals from industrial processes leave traces in sediments and ice cores. Lead pollution from Roman silver smelting shows up in Greenland ice cores. Carbon isotope ratios can indicate agricultural activity or widespread burning. Synthetic compounds like plastics, if they persist chemically even after breaking down physically, might be detectable as anomalous chemical concentrations. These signatures can survive longer than physical artifacts, potentially millions of years in the right context. The Silurian hypothesis, proposed by astrophysicist Adam Frank and climatologist Gavin Schmidt in 2018, explores this question as a thought experiment. Could we detect an industrial civilization that existed millions of years ago? They conclude that after a few million years, almost no direct physical evidence would remain. Artifacts would erode, structures would crumble, even plastics and metals would degrade beyond recognition. What might survive are chemical anomalies, unusual concentrations of carbon isotopes suggesting fossil fuel burning, synthetic compounds in sediment layers, or extinction events followed by rapid speciation, suggesting ecological collapse and recovery. The timescales matter. For anything within the past 10,000 years, the span of recorded human history, we'd expect to find substantial evidence if advanced civilizations existed. Stone foundations, ceramic artifacts, metal tools, and possibly organic materials in favorable locations would survive. The absence of such evidence from this period is meaningful. It suggests that if advanced societies existed, they didn't build in stone, use ceramics extensively, or smelt metals in large quantities. But beyond 10,000 years, the bar rises dramatically. To be detectable after 20 or 50,000 years, a civilization would need to have built extensively in stone or left chemical signatures in globally distributed sediments. Without monumental architecture or industrial pollution, even a sophisticated society could become effectively invisible. Their wooden buildings would rot, their textiles would decay, their knowledge would die with them. Visualize the decay timeline. At 100 years, iron is rust, wood is compost, paper is gone, but stone and ceramics remain intact. At 1,000 years, bronze is corroded, glass is fragmented. Most structures have collapsed, but stone monuments still stand. At 10,000 years, only stone, ceramics, and objects in exceptional preservation, contexts, survive. Everything else, the vast majority of human material culture, is gone. At 100,000 years, even stone is heavily weathered, ceramics are buried under sediments, and only chemical traces and the most durable geological signatures remain. This isn't speculation. We can observe these processes in historical and archaeological sites. Roman cities abandoned 1,500 years ago are mostly ruins. Stone foundations persist, but wooden structures, plaster, paint, furnishings, all gone. Medieval castles still have stone walls, but no wooden floors, thatched roofs, or tapestries. Egyptian tombs preserve artifacts only because they're sealed in dry chambers. Open-air sites lose organic materials within centuries. The implications for detecting lost civilizations are stark. Any society that didn't build extensively in stone would be nearly invisible after 10,000 years. If they worked primarily in wood, fiber, and leather, materials that don't survive, only their stone tools would remain. If they had sophisticated knowledge encoded in oral traditions or perishable documents, all of it would be lost. If they developed technologies using materials we don't associate with ancient peoples, bamboo, lacquered wood, plant fiber composites, we might not recognize their artifacts even if we found them. The harsh reality is this. Any civilization that didn't build extensively in stone would be nearly invisible after 10,000 years. Their tools would rust. Their buildings would collapse and decay. Their art, their books, their technologies, gone. Only geochemical anomalies in deep sediment cores might hint that something happened. This doesn't prove ancient, advanced civilizations existed, but it does prove that if they had existed and then vanished, we'd be looking in the wrong place with the wrong tools. We search for artifacts, but in deep time, artifacts don't survive. Only stone endures, and even stone forgets. If only stone survives, then we need to look at what archaeology actually finds, and more importantly, what it doesn't find when examining the deep prehistoric record. For 95% of human history, the archaeological record is nearly silent. From 300,000 years ago to about 12,000 years ago, nearly all we find are stone tools, scrapers, blades, hand axes, scattered across old campsites. No buildings, no art older than 45,000 years. No evidence of complex social organization, just stone. For a long time, this silence was interpreted as simplicity. Humans lived in small bands, surviving day to day, with no time or capacity for civilization. But maybe the silence doesn't mean absence. Maybe it means that everything except stone has decayed beyond recognition. The numbers tell the story. Anatomically, modern humans have existed for at least 300,000 years. Complex civilizations, as we define them, cities, writing, monumental, architecture, have existed for roughly 5,000 years. That leaves 295,000 years, or 98% of human existence, classified as prehistory. And for most of that time, the physical evidence of human life is vanishingly thin. A typical Paleolithic site from 100,000 years ago might contain a few dozen stone tools, some animal bones with cut marks, traces of fire, and perhaps some ochre fragments. That's it. No structures beyond possibly post holes, suggesting windbreaks or simple shelters. No preserved clothing. No tools made from wood, bone, or fiber, unless conditions were exceptional. The stone tools are there because stone survives. Everything else is missing because it decayed. Yet we know from ethnographic studies of modern hunter-gatherers that material simplicity doesn't equal cultural simplicity. The Hadza of Tanzania, the San of Southern Africa, Aboriginal Australians, and dozens of other foraging societies possess intricate knowledge systems, rich oral traditions, complex social structures, and diverse material cultures. Much of what they create is ephemeral. Temporary shelters, wooden tools, fiber baskets, body paint, sand drawings, oral stories. If archaeologists excavated a Hadza camp 10,000 years from now, they'd find stone tools, fire-cracked rocks, and perhaps some bones. The complexity of Hadza culture would be invisible. The same logic must apply to Paleolithic peoples. They created art, clothing, tools, and shelters primarily from perishable materials. They told stories, sang songs, performed rituals. They had names, relationships, conflicts, aspirations. None of this fossilizes. We recover the stone because stone is all that remains. Then we infer everything else from those fragments. Consider what doesn't survive. Wooden spears, unless charred or waterlogged, rot completely within decades. The oldest known wooden spears, from Schöningen in Germany, are 400,000 years old, but survived only because they were preserved in waterlogged clay. Without that exceptional preservation, we'd have no direct evidence that Paleolithic humans made spears, even though logic and ethnographic analogy tell us they must have. Hide clothing leaves almost no trace. The oldest known eyed needles, suggesting sewn clothing, date to about 40,000 years ago. But humans living in Ice Age Europe 200,000 years ago must have worn protective clothing to survive. We just don't find it because hide and sinew decay. The needles themselves survive only when made from bone or ivory, materials more durable than wood or plant fiber. Baskets, mats, ropes, and nets are essential technologies for hunter-gatherers worldwide. They allow transport of food and materials, construction of shelters and fish traps, and creation of clothing and bedding. Yet basketry rarely survives more than a few thousand years, unless preserved in dry caves or waterlogged sites. The absence of basketry in most Paleolithic sites doesn't mean it didn't exist. It means it rotted. Shelters present another challenge. Hunter-gatherers build sophisticated structures from wood, bark, hide, and grass. Some are substantial, designed for seasonal reoccupation. Others are temporary, abandoned after days or weeks. Even large structures leave minimal traces once the organic materials decay. Post holes might survive if they penetrated deeply into soil, but shallow structures leave nothing. We know Paleolithic peoples built shelters because survival requires them. We just can't find evidence except at a handful of exceptionally preserved sites. Art and symbolic expression face similar preservation issues. If Paleolithic peoples carved wood, painted bark shelters, decorated hides, or created sand paintings, none of it would survive. The oldest known art, cave paintings in Europe, carved figurines, engraved bones, dates to roughly 45,000 years ago. But this may represent not the beginning of symbolic expression, but merely the point where people began creating art in durable media. Earlier art in perishable materials would be invisible to us. Body ornamentation is another likely loss. Modern foraging peoples use body paint, tattoos, feathers, flowers, and shells for adornment. Most of these leave no archaeological trace. The shell beads we find from 100,000 years ago prove that personal adornment existed, but they're probably just the tiny fraction that survived, the durable beads made from mineral materials, rather than the perishable flowers, feathers, and fibers that were likely far more common. Musical expression also leaves minimal trace. Bone flutes survive because bone can fossilize, but wooden flutes, drums made from hollowed logs and stretched hide, rattles from gourds or shells, all would decay. The oldest known musical instruments date to about 40,000 years ago. But that's surely not when music began. It's when instruments started being made from materials durable enough to preserve. The concept of Paleolithic invisibility captures this problem. Most human activity leaves no lasting physical trace. A group of people living for years at a site might leave behind only stone tools and food waste if everything else they made was organic. Their full material culture the totality of objects they created and used would be represented by perhaps 1% of actual objects, the ones made from durable materials. Archaeological sites themselves are subject to destruction and burial. Many Paleolithic occupation sites would have been on coastlines, near rivers, or in valleys, precisely the places most subject to erosion, flooding, and burial under sediments. Rising sea levels submerged coastal sites, rivers changed course, eroding banks, and burying sites under alluvium. Glaciers advanced, scouring landscapes clean. Wind and water erosion removed sites entirely. The sites we find tend to be in caves or rock shelters, places protected from these destructive processes, which may not represent typical habitation patterns. There's also the issue of site recognition. A Paleolithic camp that left only a scatter of stone flakes and some discolored soil might be plowed through by farmers, bulldozed for development, or simply never recognized as archaeological. Modern survey techniques, careful surface collection, test excavations, geophysical prospecting find more sites than older methods, but we're still sampling a tiny fraction of ancient landscapes. The temporal aspect compounds the problem. The further back in time, the more sites have been destroyed, buried, or simply lost to geological processes. Sites from 10,000 years ago are more common than those from 100,000 years ago, not necessarily because populations were larger, but because more recent sites have had less time to be destroyed. Deep time is harsh on archaeological evidence. Population density matters too. If Paleolithic populations were sparse, a few million people spread across Africa, Europe, and Asia, then sites would be correspondingly rare, even if preservation were perfect. With small populations, large areas might go unoccupied for centuries or millennia, leaving vast blank spaces in the archaeological record that reflect low population rather than invisibility. Yet there are hints that Paleolithic peoples were more sophisticated than the bare archaeological record suggests. Ochre use extends back at least 300,000 years. Why collect and transport ochre unless you are using it for symbolic purposes? Body paint, hide decoration, or art on perishable surfaces. Shell beads from 100,000 years ago imply trade networks, aesthetic sense, and possibly social signaling through adornment. The earliest long-distance transport of stone materials, carrying obsidian or high-quality flint hundreds of kilometers, suggests planning and social connections beyond simple survival. Stone tool technology itself shows complexity. Different techniques for flaking stone, level way, blade production, pressure flaking, require skill, training, and cultural transmission. Master knappers pass knowledge to apprentices over years of learning. This implies social structures capable of supporting specialized knowledge and teaching. The tools we find represent not just practical implements, but accumulated expertise passed down through generations. Fire use shows similar sophistication. Controlled fire requires knowledge of fuel types, ignition methods, and fire maintenance. It implies planning, collecting and storing fuel, choosing camp locations with fire safety in mind. Early evidence for fire use extends back at least 1 million years with Homo erectus, and by 300,000 years ago, modern humans were using fire routinely. That's hundreds of thousands of years of fire technology, suggesting deep traditions of knowledge about combustion, fuel, and heat management. The silence of deep prehistory is deafening. But silence can mean many things. It might mean humans really were living simple lives, surviving but not thriving. Or it might mean that they were thriving in ways that don't survive, building with wood, wearing woven cloth, creating art on bark and hide, passing knowledge through song. The stone tools we find may be only the tiniest fraction of what they actually made. And if 250,000 years of human ingenuity is invisible because it was expressed in perishable materials, then the silence isn't emptiness, it's erasure. The silence of deep time is one problem. But even within recent prehistory, the past 20,000 years, new discoveries keep pushing back timelines and challenging assumptions about when humans could do what. Every decade brings revelations that force us to reconsider. Until 1994, archaeologists believed that monumental architecture required agriculture, settled populations, and social stratification. Then, Göbekli Tepe was discovered, and that assumption shattered. Until 2017, the oldest Homo sapiens fossils came from Ethiopia and were dated to around 195,000 years ago. Then new finds in Morocco pushed the date back to 315,000 years. Until 2019, researchers thought modern humans reached the Americas around 13,000 years ago via the Bering land bridge. Then footprints in White Sands, New Mexico, dated to 23,000 years ago, forced a complete revision. Every few years, a discovery emerges that doesn't fit the timeline. Each time, we adjust. And each time we wonder, what else are we wrong about? The pattern of revision is consistent. We underestimate the age of human achievements until evidence forces us to reconsider. This happens across multiple domains: art, technology, migration, social complexity. And it happens regularly enough to suggest a systemic problem with how we interpret the past based on limited evidence. Cave art provides a clear example. For decades, Europe was considered the birthplace of artistic expression, with the oldest known cave paintings dating to roughly 40,000 years ago in France and Spain. Then, in 2018, researchers dated paintings in Indonesian caves to at least 44,000 years old, making them contemporary with or older than European examples. In 2021, a pig painting in Indonesia was dated to 45,500 years ago, currently holding the record for oldest known figurative art. Each new find pushes the dates back and expands the geography, suggesting that artistic expression was far more widespread and ancient than previously recognized. Seafaring capability underwent similar revision. Conventional wisdom held that humans didn't develop deep water navigation until relatively recently, perhaps within the last 10,000 years. But the settlement of Australia at least 65,000 years ago required water crossings. Even during low sea levels, gaps between islands were too wide to see across, meaning voyagers were traveling into the unknown, beyond sight of land. That implies intentional seafaring with sufficient technology to cross dozens of kilometers of open water. This capability existed tens of thousands of years earlier than researchers once thought possible. The same pattern appears with cognitive sophistication. Shell beads from Blombos Cave in South Africa, dated to 75,000 years ago, show evidence of personal ornamentation far earlier than expected. Engraved ochre pieces from the same site demonstrate abstract symbolic thought. These finds pushed behavioral modernity back by tens of thousands of years, challenging theories that claimed symbolic thinking emerged suddenly around 50,000 years ago. Burial practices keep getting older. Intentional graves dated to around 100,000 years ago have been found in the Middle East, with bodies placed in specific positions and accompanied by objects. This suggests concern for the dead, possible belief in afterlife, and social complexity that orthodox chronologies didn't predict for this time period. Each new burial find extends the timeline of symbolic and ritualistic behavior further into the past. Tool complexity shows the same trend. Pressure flaking, a sophisticated stoneworking technique producing thin, sharp blades, was thought to emerge around 20,000 years ago. Then tools using this technique were found dating to 75,000 years ago in Africa. Composite tools, where multiple materials are hafted together with adhesives, appear much earlier than once believed. The Schöningen spears from Germany, 400,000 years old, are carefully shaped throwing spears that required sophisticated understanding of wood properties and weapon ballistics. Each discovery reveals that ancient peoples were more capable than we credited them. Long-distance trade networks also predate expectations. Obsidian from specific sources has been found hundreds of kilometers from its origin in contexts dating to 100,000 years ago or more. Shell beads from the coast appear in inland sites across significant distances. These movements of materials imply either direct travel, which requires knowledge of geography and navigation, or trade networks connecting distant groups, both indicators of social complexity. The settlement of remote islands continues to surprise researchers. The human presence on Flores in Indonesia extends back at least 1 million years, requiring water crossings by Homo erectus, a species not known for seafaring. Crete shows evidence of human presence 130,000 years ago, also requiring sea travel. Each of these finds challenges assumptions about the cognitive and technological requirements for crossing water. Language capability, while not directly observable in fossils, can be inferred from anatomy and genetics. The FOXP2 gene associated with speech shows signs of selection around 300,000 years ago, suggesting fully modern language capacity existed from the beginning of Homo sapiens. This contradicts older theories that place language development much more recently. If language was present from the start, then teaching, storytelling, and cultural transmission of complex knowledge were possible throughout human existence. They just didn't leave physical traces. Fire use provides another example. Once thought to be a relatively late development, controlled fire use now appears to extend back at least 1 million years. By 400,000 years ago, habitual fire use is well established. This means hundreds of thousands of years of fire technology before modern humans even emerged. The accumulated knowledge of fire management, fuel types, and thermal applications represents a long tradition we can barely glimpse through charcoal traces. Dwellings, when we find them, are often more complex than expected. At Ohallo II in Israel, a 23,000-year-old site preserved by being submerged in the Sea of Galilee, archaeologists found remains of substantial brush huts with evidence of repeated occupation. These weren't crude shelters, but carefully constructed dwellings designed for comfort and reuse. Similar finds elsewhere suggest that Paleolithic architecture, when preservation allows us to see it, was more sophisticated than the absence of evidence usually implies. Cooking technology also has deeper roots than once assumed. Grinding stones for processing plant foods appear much earlier than the development of agriculture, suggesting that complex food preparation existed among hunter-gatherers. Heated stones for boiling liquids, earth ovens for slow cooking, and specialized tools for processing different foods all appear in contexts earlier than traditional models predicted. Astronomical knowledge, as evidenced by deliberate alignments of structures and possibly notations on bones and stones, may extend back further than monumental architecture suggests. Marks on bones from 30,000 years ago have been interpreted as lunar calendars, though this remains controversial. Even if not calendrical, the marks demonstrate systematic notation of some kind, a precursor to writing that existed in the deep Paleolithic. The Americas provide particularly dramatic revisions. For most of the 20th century, the Clovis culture, circa 13,000 years ago, was considered the first human presence in the Americas. The Clovis first model dominated American archaeology. Then pre-Clovis sites began accumulating. Monte Verde in Chile, 14 to 3,500 years old. Meadowcroft Rock Shelter in Pennsylvania, possibly 16,000 years old. And others. The White Sands footprints, 23,000 years old, shattered the remaining consensus. Now, researchers are seriously considering human presence in the Americas as early as 30,000 years ago, perhaps even earlier. Each date revision requires rethinking migration routes, population sizes, and cultural development. The cognitive revolution hypothesis that a sudden mutation around 50,000 years ago enabled symbolic thinking looks increasingly untenable as evidence of earlier symbolic behavior accumulates. The explosion of art and artifacts in the Upper Paleolithic may reflect population growth, improved preservation, or better archaeological visibility, rather than a sudden cognitive leap. Humans may have been fully behaviorally modern from the beginning, with material expressions of that modernity, depending on environmental conditions, population density, and, most significantly, what materials they chose to work with. Each revision follows a similar pattern. Initial discovery is met with skepticism. Dating is challenged. Alternative explanations are proposed. Eventually, additional evidence accumulates, and the new date or capability is grudgingly accepted. Textbooks are revised, models are updated. And then another discovery pushes the boundaries again. The implication is unsettling. If we consistently underestimate when humans could do something by tens of thousands of years, what else are we underestimating? Are there capabilities or achievements that existed but left no trace, or left traces we haven't recognized? The archaeological record is not a video of the past. It's a series of snapshots with most frames missing. We're reconstructing a movie from scattered images, and every few years we find another image that doesn't fit the sequence we've constructed. Academic archaeology is conservative by necessity. Extraordinary claims require extraordinary evidence. This is healthy skepticism. It prevents premature acceptance of flawed interpretations. But it also means that new discoveries, especially those challenging established chronologies, face resistance. By the time consensus shifts, the evidence is overwhelming, which raises the question, how much evidence is missing because we haven't found it yet, versus how much has been found but not yet accepted? The past 20 years have brought more revisions to human prehistory than the previous 50. Better dating techniques, wider geographic survey, improved analysis methods, and simple luck have all contributed. Göbekli Tepe was always there. It just took until 1994 for someone to recognize it. The Indonesian cave paintings were always there. It took advanced dating methods to determine their age. The White Sands footprints were always there, buried under sediment until erosion exposed them. What else is out there, waiting? or sites remain undiscovered, buried under forests or deserts or seas? What artifacts sit in museum storage, mislabeled or misunderstood, their true significance unrecognized? What capabilities did ancient peoples possess that left no durable trace, making them invisible to archaeological methods? The pattern suggests we should be humble about our chronologies. Every fixed date is provisional. Every established capability boundary is subject to revision. And every assertion about what ancient people couldn't do should be qualified with as far as we currently know. Every few years, we discover that humans were doing something 10,000, 20,000, 50,000 years earlier than we thought. We keep underestimating them, which raises an uncomfortable question. If our timelines are consistently wrong in one direction, always too recent, never too ancient, what does that say about our baseline assumptions? Maybe the real lesson is simpler. Humans have always been capable. We're the same species we've always been. And maybe, just maybe, we've always been building civilizations. We just built most of them from materials that rot. If our baseline assumptions keep proving wrong, then we need to confront a final question. Have we been looking for lost civilizations in the wrong way? When we ask, were there lost civilizations? We're usually imagining Atlantis, gleaming cities with advanced technology, swept away by catastrophe, leaving only myths. But maybe we're asking the wrong question. Maybe the real question is, what forms of human sophistication leave no archaeological trace? Because if knowledge can be carried in memory, if technology can be built from wood and fiber, if astronomy can be encoded in oral tradition and seasonal rituals, then civilization, in the sense of accumulated knowledge and cultural complexity, could exist and vanish completely, leaving nothing but stone tools and scattered bones. The evidence we've examined doesn't prove that advanced ancient civilizations existed. It proves something more unsettling, that vast portions of human capability and achievement are invisible to archaeology. The Antikythera mechanism shows that sophisticated technology can be lost so completely that when rediscovered, no one recognizes what it is. The Denisovans proved that entire human species can thrive for hundreds of thousands of years and leave almost nothing behind. Aboriginal oral traditions demonstrate that knowledge can survive 10,000 years without writing. Göbekli Tepe reveals that our models of social development are incomplete. Each piece of evidence, taken alone, is interesting but not revolutionary. Taken together, they sketch the outline of a problem. The archaeological record is systemically incomplete. Stone survives. That's the foundation of prehistoric archaeology. We find stone tools, stone monuments, stone foundations. From these durable remnants, we infer everything else: social organization, cognitive capacity, cultural complexity. But what if stone represents only a tiny fraction of what ancient peoples actually created? What if the real achievements were in materials that decay, knowledge systems that left no artifacts, or technologies we wouldn't recognize even if we found them? Consider what a lost civilization might actually mean if we strip away the Atlantis mythology. Not gleaming cities of marble and gold, but cultures with sophisticated astronomical knowledge encoded in wooden calendars that rotted away. Not written libraries, but oral traditions carrying tens of thousands of years of accumulated observation about plants, animals, and landscapes, traditions that died when the cultures collapsed. Not advanced metallurgy, but mastery of organic materials, woven textiles that rivaled later cloth but decayed within centuries, composite wood and fiber technologies that left no trace, architectural systems using bamboo or timber that were as sophisticated as stone construction but vanished completely. This isn't speculation for its own sake. We know from ethnographic studies that material simplicity doesn't equal cultural simplicity. The Aboriginal Australians, when Europeans arrived, possessed no agriculture, no permanent architecture, no writing, and only the simplest stone tools. By conventional archaeological standards, they represented a primitive stage of development. Yet they maintained one of the world's most complex kinship systems, sophisticated ecological knowledge spanning continental geography, astronomical traditions that tracked celestial cycles, and oral histories stretching back 10,000 years. But Aboriginal culture had been destroyed 12,000 years ago, and archaeologists excavated the sites today. They'd find stone tools and little else. The entire richness of the culture would be invisible. Scale this up. Imagine a culture that existed in the Amazon basin 15,000 years ago. They built in wood and palm thatch. They wove intricate textiles from plant fibers. They cultivated forest gardens with hundreds of edible plants. They had complex social hierarchies, astronomical knowledge, healing traditions using medicinal plants, and oral histories going back thousands of years. They thrived for 5,000 years. Then climate shifted, populations declined, and the culture vanished. What would remain? In the tropical environment with high rainfall, intense biological activity, and acidic soils, almost nothing. Stone tools, if they used them. Perhaps some terra preta, enriched soil from long habitation. Maybe shell middens, if they lived near rivers. But the civilization itself, the knowledge, the social structures, the technologies, would be completely gone. This thought experiment isn't about proving such cultures existed. It's about establishing what could exist without leaving detectable archaeological traces. And the answer is quite a lot. Any culture that built primarily with organic materials, that transmitted knowledge orally rather than in writing, that worked in perishable mediums, and that existed in environments where preservation is poor, could be effectively invisible after 10,000 years. The mainstream archaeological response to lost civilization theories has traditionally been, where's the evidence? And that's a fair question. Extraordinary claims require extraordinary evidence. But it's worth examining what we mean by evidence. If we define evidence as durable artifacts, stone, ceramics, metal, then absence of evidence is meaningful. It suggests that whatever existed didn't work those materials extensively. But if we acknowledge that most human material culture is perishable, then absence of durable artifacts doesn't tell us much about what existed in perishable forms. This creates an epistemological problem. How do we distinguish between didn't exist and existed but didn't survive? In cases where we have written records or clear cultural continuity, the distinction is easier. We know Roman engineering was sophisticated because Roman texts describe it, and because some Roman structures survive. We know Polynesian navigation was sophisticated because oral traditions preserve the knowledge, and because the settlement pattern of Pacific islands demonstrates its success. But for prehistoric cultures with no writing and no clear descendants, we're left inferring capability from a tiny sample of durable artifacts. The concept of behavioral modernity illustrates this challenge. For decades, archaeologists used the appearance of art, complex tools, and symbolic artifacts around 40,000 years ago to mark the point where humans became fully modern. Earlier humans were considered cognitively or behaviorally different. But as evidence of earlier symbolic behavior accumulates, shell beads at 100,000 years, engraved ochre at 75,000 years, sophisticated tools at increasingly early dates, the behavioral modernity threshold keeps being pushed back. Now, many researchers argue that humans were behaviorally modern from the beginning, and the apparent explosion of culture 40,000 years ago reflects changes in preservation, population density, or material choices rather than cognitive evolution. If that's correct, then for 250,000 years, humans with brains identical to ours, living in small groups across Africa and eventually beyond, were creating cultures we can barely glimpse. They told stories, made music, painted their bodies, sewed clothing, built shelters, taught their children, remembered their dead. Almost none of it survives. The cultures themselves were as real and complete as any historical civilization. But time has erased them so thoroughly that we can barely prove they existed as anything more than simple survival. The genetic evidence compounds the mystery. Mitochondrial Eve and Y-chromosomal Adam show that most human lineages went extinct. The Toba bottleneck suggests that populations crashed dramatically. Ghost populations prove that entire human species interbred with our ancestors and then vanished without leaving fossils. Each of these discoveries reveals how much has been lost, not just artifacts, but entire genetic lineages, entire populations, entire branches of the human family tree. If humans and their close relatives can disappear this completely at the genetic level, how much easier for their cultural achievements to vanish? The question of lost civilizations is often framed as believers versus skeptics, alternative researchers versus mainstream academics. But that's a false dichotomy. The real question isn't whether to believe in Atlantis, but how to think about the limits of archaeological knowledge. Mainstream archaeology has demonstrated convincingly that large-scale urban civilizations didn't exist before roughly 6,000 years ago. There are no buried cities, no roads, no agricultural field systems, no large-scale architecture older than that, except hunter-gatherer monuments like Göbekli Tepe. That's settled. But whether sophisticated cultures with complex knowledge systems and impressive capabilities existed without leaving urban remains is a different question entirely, and one that current methods can barely address. There's a middle ground that's often overlooked. Maybe there were no lost civilizations in the conventional sense, no advanced technologies, no cities drowned by rising seas, no ancient global empires. But maybe there were cultures far more sophisticated than the stone tools suggest. Cultures that developed deep astronomical knowledge, complex social organizations, sophisticated understanding of medicine and ecology, and impressive artistic and engineering capabilities, all expressed in forms that didn't survive. If we found evidence of such cultures tomorrow, would we recognize it? Or would we classify it as hunter-gatherers with interesting traditions and move on? The preservation bias is real and severe. Most human activity leaves no permanent trace. The archaeological record captures perhaps 1% of past human material culture, and that 1% is heavily biased toward durable materials and favorable preservation environments. For the deep past, the percentage is even lower. We're reconstructing human history from scattered fragments, then arguing about what the complete picture looked like based on whether we've found 50 fragments or 100. This doesn't mean anything is possible. It doesn't validate every wild claim about ancient astronauts or precessional codes. But it does mean that epistemological humility is warranted. The absence of evidence for X doesn't prove X didn't exist. It proves only that if X existed, it didn't leave traces we've found. And for the deep prehistoric past, the range of X that could exist without leaving traces is larger than we usually acknowledge. So were there lost civilizations? If by civilization we mean cities, writing, and monumental stone architecture, the answer is almost certainly no, for anything older than about 10,000 years. The evidence simply isn't there, and the absence is meaningful. But if by civilization we mean cultures with accumulated knowledge, complex social structures, sophisticated capabilities, and rich traditions, cultures that saw themselves as accomplished and that would have resisted being called primitive, then the answer is almost certainly yes. Those cultures existed throughout human history. Most of them left so little trace that we can barely detect them, and what we do find, scattered stone tools, a few bones, traces of fire, gives no hint of the full richness of what was there. The Piri Reis map might show Antarctica, or might show cartographic speculation. The Baghdad battery might be a battery, or might be a scroll case. The Vimanas might describe ancient aircraft, or might be mythology. The Sphinx might be older than we think, or might not. Each individual claim is ambiguous. But the cumulative picture they point to, a picture of human capability obscured by time, erased by decay, and rendered invisible by our methods, that picture has merit. Not because any single anomaly proves it, but because the systematic biases in how we know what we know suggest it. The real lost civilizations might not be the dramatic Atlantises of mythology. They might be quieter, the master woodworkers whose entire corpus of art dissolved in tropical humidity, the astronomers who tracked stars for generations, encoding observations in songs that died when their singers did, the herbalists who knew 10,000 plant properties but left no written pharmacopoeia, the architects who built magnificent structures from bamboo and timber that rotted away, the navigators who crossed oceans using stars and wave patterns, leaving no charts, the philosophers whose wisdom was never written down, the cultures that thrived for thousands of years and vanished so completely that their absence looks like emptiness rather than loss. We've been searching for lost civilizations by looking for stone monuments and metal tools. But what if the real achievements were knowledge systems carried in memory, technologies built from fibers and wood, and cultural sophistication that expressed itself in ways that don't fossilize? What if the lost civilizations aren't lost because they were destroyed by cataclysm, but because they were built from materials that naturally decay? What if they've been there all along, in the gaps between the stone tools, in the silence of the deep past, in the cultures we dismissed as primitive because all we found was their most durable debris? The archaeological record is not a complete picture of human history. It's the tiny fraction that survived. And if that fraction is biased towards certain materials, certain environments, certain types of activity, then what survives tells us more about preservation than about capability. The absence of pyramids doesn't mean absence of architectural knowledge. The absence of texts doesn't mean absence of accumulated wisdom. The absence of metal tools doesn't mean absence of technological sophistication. Were there lost civilizations? The honest answer is, we don't know. And depending on what we mean by civilization, we might never be able to know. What we can say with confidence is that humans have been anatomically and cognitively modern for hundreds of thousands of years, that most of what they created has vanished, and that the archaeological record preserves only the most durable remnants of their existence. Everything else, perhaps most of human achievement, exists now only as silence, and silence, as we've learned, can mean many things. Sometimes it means nothing was there, but sometimes it means everything was there, and time erased it so completely that absence looks like emptiness rather than loss. The question isn't whether to believe in lost civilizations. The question is whether to believe that a gap in the archaeological record means a gap in human capability. And after examining the evidence, the mechanisms of preservation, the patterns of discovery, the systematic biases in what survives, it's hard to maintain that belief with confidence. The past is not empty, it's erased. And there's a difference. So what do we actually know? We know that humans have been anatomically modern for at least 300,000 years. We know that for most of that time, the archaeological record is nearly silent. We know that preservation is severely biased towards stone and ceramics. We know that oral traditions can preserve accurate information for 10,000 years or more. We know that sophisticated technologies like the Antikythera mechanism can be lost completely. We know that entire human species like the Denisovans can exist for hundreds of thousands of years and leave almost nothing behind. We know that our timelines keep getting pushed back. Art is older. Seafaring is older. Symbolic thinking is older than we thought. And we know that most human material culture, built from wood and fiber and hide, decays within centuries or millennia at most. What does all of this add up to? Not proof of ancient advanced civilizations in the Atlantis sense. There's no evidence for cities, writing systems, or monumental stone architecture older than about 10,000 years, and that absence is meaningful. The archaeological survey of Earth is incomplete, but not that incomplete. If stone cities existed 50,000 years ago, we'd have found them. If metallurgy was widespread 100,000 years ago, we'd see chemical signatures in ice cores and sediments. The baseline of urban civilization, the kind of civilization we recognize from history, doesn't extend deep into prehistory, but that doesn't mean the past was simple. It means the past was different. Hunter-gatherer societies, which we've tended to view as developmentally arrested way stations on the road to civilization, may have possessed cultural and intellectual sophistication that simply expressed itself in forms that don't survive. The knowledge systems of the San people, the navigation expertise of Polynesians, the ecological mastery of Aboriginal Australians. These represent genuine civilizational achievements, even though they don't look like Rome or Egypt. They're different forms of human excellence, adapted to different environments and organized around different values. The archaeological invisibility of such achievements creates a profound challenge. How do we write the history of cultures that left no texts, built no stone monuments, and worked primarily in materials that decay? The honest answer is that we can't. Not completely. We can detect their presence through stone tools and occasional preserved items. We can infer some aspects of their lives through analogy with modern foraging peoples. But the full richness, the stories they told, the songs they sang, the relationships they navigated, the knowledge they accumulated is gone. Not because they didn't have these things, but because they had them in forms that don't fossilize. This creates what we might call the problem of epistemological humility. We know the archaeological record is incomplete. We know preservation is biased. We know our chronologies keep being revised backward as new evidence emerges. Given all this, how confident should we be in negative claims, assertions that something didn't exist because we haven't found it? The answer depends on what we're claiming. Can we confidently say there were no stone pyramids in Antarctica 100,000 years ago? Yes, because such structures would survive and be detectable. Can we confidently say there were no sophisticated oral astronomical traditions in Central Asia 30,000 years ago? No, because such traditions would leave minimal archaeological trace. The grey zone between these extremes is where the interesting questions live. Could there have been cultures with extensive botanical knowledge, sophisticated social organization, and complex belief systems that left only stone tools behind? Almost certainly. Could there have been master craftspeople working in wood, fiber, and bone, who created objects of great beauty and utility that have all decayed? Obviously. Could there have been astronomers tracking celestial cycles for generations, passing knowledge through song and story, leaving no written records? Yes, we know this happened in some documented cases, so it likely happened in undocumented ones too. But at some point, claims about past capabilities need to be grounded in something more than possibility. Saying X could have existed is different from saying X did exist. The former is a statement about preservation and epistemology. The latter is a historical claim requiring evidence, and this is where mainstream archaeology's skepticism is healthy. Without evidence, we're just speculating. With evidence, we have something to analyze and debate. The tension between these positions, the possibility of unseen sophistication versus the demand for evidence, defines the lost civilization debate. Alternative researchers point to anomalies, gaps, and the limitations of archaeology to argue that ancient advanced cultures could have existed. Mainstream scholars point to the absence of definitive evidence and the coherence of the standard model to argue that such cultures almost certainly didn't. Both positions have merit within their domains. What we're left with is a landscape of gradations. High confidence, urban civilizations with writing and monumental architecture don't extend before about 6,000 years ago. The earliest known examples, Uruk, Egyptian cities, Harappan civilization, cluster around that time frame, with earlier precursors, but nothing dramatically older. Medium confidence, complex hunter-gatherer, societies with sophisticated knowledge systems and impressive capabilities existed throughout prehistory, but built primarily in perishable materials. This is consistent with known examples and archaeologically invisible. Low confidence, specific claims about ancient maps, batteries, flying machines, or precision megalithic technologies. These rest on ambiguous evidence subject to multiple interpretations. The implications extend beyond archaeology. They touch on how we understand progress, civilization, and human nature. The traditional narrative that humanity evolved culturally from simple to complex, from primitive to advanced, in a more or less linear trajectory, doesn't hold up to scrutiny. Complexity is ancient. Humans 40,000 years ago had brains identical to ours. They were not less intelligent or less capable in any neurological sense. They simply lived in different circumstances with different resources and priorities. A Paleolithic person transported to the modern world would struggle, but so would we if transported to theirs. Capability is context dependent. This also raises questions about what we value and recognize as achievement. Stone monuments survive, so we credit cultures that built them. Oral traditions decay, so we undervalue cultures that specialized in them. Writing preserves knowledge, so we see literate societies as more advanced. But is the ability to carve stone really a better measure of human achievement than the ability to navigate by stars, to remember genealogies stretching back dozens of generations, or to maintain ecological relationships with hundreds of plant and animal species? We've conflated durability with importance, assuming that what survives must have been what mattered most. The search for lost civilizations, at its best, is really a search for lost humanity, the parts of our story that time erased. It's not about finding Atlantis or validating ancient astronaut theories. It's about recognizing that the archaeological record is a narrow window into the past, and that beyond that window were real people with real lives, real knowledge, and real achievements that we can barely glimpse. They were not primitives waiting for history to begin. They were humans, fully modern in cognition and capability, living in ways adapted to their environments and expressing their humanity through means that don't always survive as artifacts. The evidence we've examined points to several conclusions. First, sophisticated capabilities appear earlier and more widely than traditional models predicted. Art, symbolism, complex tools, astronomical knowledge, seafaring, all are older than we once thought. Second, preservation profoundly shapes what we find. Most human activity leaves no permanent trace, biasing the record towards certain materials and environments. Third, oral traditions can preserve information for extraordinary lengths of time, meaning that cultures without writing could still accumulate and transmit complex knowledge. Fourth, catastrophes and demographic changes can erase lineages, populations, and cultures completely, making recovery of their achievements difficult or impossible. Fifth, our chronologies are constantly being revised as new evidence emerges, suggesting systematic underestimation of past human capabilities. None of this proves that advanced ancient civilizations existed in the way alternative researchers imagine. But it does prove that the past was richer, more complex, and less accessible than we often assume. The silence of deep time is real. The gaps in the archaeological record are real. The systematic biases in what survives are real. And the accumulated weight of these realities suggests that humility about what we know and what we can know is warranted. Perhaps the most important lesson is that absence of evidence is not the same as evidence of absence, especially for phenomena that wouldn't leave durable traces. We should be confident in what the evidence positively shows: stone tool traditions, the development of agriculture, the rise of cities. We should be cautious about negative claims regarding perishable technologies, oral traditions, and capabilities that wouldn't leave archaeological signatures. And we should remain open to revision as new evidence emerges, because the history of archaeology is largely a history of discovering that humans were doing things earlier, in more places, and with more sophistication than previous models predicted. The question of lost civilizations will continue to generate debate, speculation, and research. As underwater archaeology advances, as new sites are discovered, as dating techniques improve, we'll learn more about what actually happened in deep prehistory. Some claims will be validated, others will be debunked. The chronologies will shift. The models will be refined. That's how knowledge progresses, through accumulation of evidence and revision of interpretations. But some things will remain unknowable. The songs sung around Paleolithic campfires, the stories told to explain the stars, the names people called each other, the relationships they navigated, the dreams they had, the knowledge they carried in memory and passed to their children. Most of human experience doesn't fossilize. It happens. It matters intensely to the people living it, and then it's gone. Not because it wasn't real or important, but because reality and importance don't guarantee preservation. We are the inheritors of 300,000 years of human experience, but we have access to only the tiniest fraction of that inheritance. The rest is silence. And whether we interpret that silence as emptiness or as erasure, as evidence of simplicity or evidence of perishability, shapes how we understand not just the past, but ourselves. We are not the first complex humans, not the first to look at the stars and wonder, not the first to create beauty and meaning from the materials at hand. We're just the first whose creations, built from concrete and steel and preserved in writing, might actually survive long enough to tell the full story. Or maybe not. In another 10,000 years, will archaeologists excavate our ruins and find only stone foundations and ceramic fragments? Will they reconstruct our civilization from garbage dumps and conclude we were simple people with basic needs? Will they miss the art in museums, the books in libraries, the knowledge in data centers, all of it decayed, dissolved, destroyed? Will they look at our remains and ask the same questions we ask about the Paleolithic? Where's the evidence of complexity? Where are the achievements? Perhaps the question of lost civilizations is ultimately a mirror. It reflects our assumptions about progress, preservation, and the nature of human achievement. It challenges us to think beyond stone and metal, beyond writing and monuments, to recognize that human excellence takes many forms. And it reminds us that everything we build, everything we know, everything we think will last. All of it is temporary. Time erases, cultures vanish, knowledge is lost, and after enough millennia, even civilizations leave barely a trace. Were there lost civilizations? Maybe. Probably not in the sense that fringe theorists imagine, but possibly in ways we haven't fully recognized or can't detect with our current methods. What's certain is that there were lost people, billions of humans who lived, loved, learned, and died without leaving any record we can read. Their lives were as real as ours. Their experiences were as rich. Their capabilities were as developed. They simply didn't encode their existence in forms that survived tens of thousands of years. And so they're lost, not because they were primitive or unimportant, but because time is cruel and preservation is rare. The past is not a museum where everything is carefully preserved and labeled. It's a vast graveyard where almost everything has decomposed. leaving only scattered bones and the hardest stones. From these fragments, we reconstruct what we can. We tell the story we're able to tell. But we should never forget that it's incomplete, that the silence is louder than the evidence, and that beneath the surface of what we know lies an ocean of what we've forgotten. That's the real mystery. Not whether ancient astronauts visited Earth or whether Atlantis existed, but how much of human achievement has been erased so completely that we don't even know to look for it. How many discoveries were made and lost? How many traditions flourished and faded? How many peoples lived entire histories that are now compressed into a handful of stone tools and a few paragraphs in an archaeology textbook? We'll never know. And maybe that's the answer we should embrace. Not the tantalizing certainty of lost cities beneath the waves, but the humbling uncertainty of gaps we cannot fill and knowledge we cannot recover. The past is gone, not hidden, not encoded in mystical maps, not waiting to be discovered intact, gone. And what remains are echoes, fragments, traces so faint that we argue over their meaning. But those echoes tell us something important. They tell us that humans have always been human, curious, creative, capable. They tell us that knowledge is fragile and preservation is precious. They tell us that most of what we build won't last. Most of what we know won't be remembered. And most of who we are won't leave a trace. And they tell us that despite this, despite the certainty of being forgotten, humans keep building, keep learning, keep creating meaning from chaos. That's not a lost civilization. That's just civilization. And it's been happening in one form or another for 300,000 years. Most of it is gone now. Only the stones remain. And the stones, as we've learned, remember almost nothing.